Hello, and welcome. Welcome to a full beginner course in which I will teach you basic product presentation techniques, be it small scale or large scale, in Unreal Engine 5. And I guess it's best for me to show you the final result before we actually begin, so that you can see what to expect. So here, at the end of this course, you will have a folder. In that folder, you'll have an exe file that anyone that you send the file to will be able to open. If you open this file, and before I do so, let me hide my camera for maximum immersion. So once you open this file, you will see the product being presented. And here you will have the chance to change cameras. Also, there's a little bit of a sound there. Maybe the sound is a little bit too high. I don't know. If it's too high, I'm sorry. Changing cameras. The cameras do move on their own a little bit. Some close-ups. Your product will be able to be exploded and looked at from, of course, different views, constructed again. You'll be able to change the style of the product. And you'll be able to change between different environments. In this case, we're in the studio scene, we can change to the interior scene. Just give it a second to load in. Right? Same thing for here. There are different cameras. I like this one. There are different styles. Just give it a second for the textures to kick in. Right? And also here you can deconstruct and reconstruct your object. And that's basically it. That's the whole app that we're going to be creating. So I guess we begin with Chapter 1. Actually, before we begin, just a small little note. It's also possible to send these files through the internet, right? So to open them up in the browser, and I'll talk about that at the end of the video a little bit more once we actually have a project to send. But this whole project is currently playing off of a browser, and it works exactly the same way as how it worked in the standalone version on my computer, except that it does not require any resources. Meaning that if you send this, or if you incorporate this into your website, your client can access it even from a phone, and it will not require any resources of the client's phone or the hardware on the client side, which is very nice. Again, it's called Arcane Mirage. If you want to read up on it before we go on with the course, you can, but the whole tutorial on how to upload it to the internet and use it on the servers of Arcane Mirage is going to be at the end of the video. Now we're ready to go to Chapter 1. Before you begin with Unreal Engine, you do need to have geometry that you will be showcasing in Unreal Engine. Unreal Engine itself is not great for 3D modeling purposes, thus you need to have geometry created in either CAD software or non-CAD software. And I have two examples of that here. I have my Rhino file on the right-hand side, and I have my Blender file on the left-hand side. And I will be primarily using the Rhino file for exporting and so on, but in principle, the whole workflow is the same. You need to have geometry that is properly UV unwrapped and is ready to go in terms of exporting it into Unreal Engine. So let me first of all guide you through the Blender logic, right? Here I have this desk, this form that is scaled to the correct scale. That is important, and also that is anchored to 0, 0, 0 coordinate of the world, right? So those are two key things. If you're not familiar with either 3ds Max or Blender or so on, like in terms of 3D modeling, I strongly suggest that you first learn how to 3D model and then start learning how to present your 3D models. That would make more sense. Anyway, so key thing here is to have the object in the correct scale and to have the correct units. Unreal Engine uses centimeters as its unit base. If you don't use centimeters in your exported file, Unreal Engine will, and importers will try to scale the imported object accordingly to what kind of unit was used, for instance, inches to centimeters. But honestly, it's much better if you just have centimeters from the start. So here, if I go to scene in my Blender file, scene, under unit system, I choose metric, and then under length, I choose centimeters. And that's gonna do the trick. Then all you need to do is just, let's go for the side view, just some, how do you call it? Making sure that you're not losing your mind, right? Just measuring from one point, you can see I made a bunch of measures beforehand. From one point to the other, I see 120, around 120 centimeters. We're good to go with that. It's okay, it's ready to be exported. To export something from Blender into Unreal Engine, you use FBX format. You can use OBJ, that is true, but I noticed that FBX tends to import more cleanly. One thing before I forget, also your geometry does need to be properly UV unwrapped so that the textures map correctly, right? So there's the whole UV editing tab where you can see the UV islands. These geometries are separate, right? They have been imported separately, thus the UV islands overlap. Either way, with that being said, to export this, you go to File, Export, FBX. I'll just create a new folder, call it Export from Blender. Double click that, and here you can just copy the settings that I'm using. I'm not sure if I've changed any settings. Forward is -Z forward, up, Y is up. FBX does really like to flip your coordinate systems around, so that seems to be remapping everything correctly. And that's it, you export FBX. One thing to note is if you have any transformations applied to the object, such as scale, move, or rotate, you should apply those transformations before you export. Meaning, if I select my object and I go to Object, Apply, All Transforms, now it's going to be exported properly. If I don't do that, the scale, the rotate, and everything else might not trigger. And it might still be in incorrect position as well as incorrect scale. Anyway, now if I export again, FBX, like that, sure. The name doesn't matter, export. That's it, you're done. You're ready to have this geometry imported into Unreal Engine. Now for Rhino. For Rhino, it's the same principle, right? Your model here, let me hide the surrounding environment. Your model needs to be centered around 0, 0, 0 coordinate, right? Because it's much easier then to catch it and to find where different objects are, and it's just less of a mess. So make sure that that is the case. Then if you type in units, here you can see I have set it to centimeters. If I measure distance from here to here, you can see it's 120 basically centimeters. It's less because of the bevel, right? And all of my elements in the Rhino file are separated into separate entities, separate pieces, as they should be in your Blender file as well, separate objects that will later be moved in Unreal Engine, as you saw in the exploded diagram view, right? So that's the reason why I'm modeling everything separated. One more thing is every piece of geometry here is actually unwrapped. If I were to show you this in, let's say, rendered view. Okay, that part is glitching out. Don't worry about that. This is literally a UV editor or UV preview mistake. Besides that, everything else seems to be doing a-okay. If I were to show you this particular leg, let's isolate it out. UV editor, draw a rectangle. You can see all of the islands of this leg drawn out here, right? So we have the front face, we have the back face, and we have the in-between, this seam right here, right? So if you're not familiar with how to unwrap geometries in in Rhino, then I will leave a link somewhere here in the video description probably, showcasing that. With that being said, if you want to follow along this course without actually using your own geometry, you can by downloading all of the files. I will make all of the files available that I use in this course in the video description below for Patreon supporters. If you support the channel, you can follow along with the geometry that I have created. But of course, if you have your own geometry, just use that. So all of the files that we do on this channel are available to Patreon supporters. Again, link in the video description below. Now, in terms of exporting this, I will export it as two separate files, I believe. I will export this bench. Let me type in export, enter. I'll export this bench and let's go for new folder, exports from Rhino, right? I'll choose FBX format, as I should, Motion Builder FBX, and I'll call this bench or T1, T2. T1, T2 means table 1 type 2. We have a lot of designs in Very Good Architecture Company of many different furniture pieces. This is one of them. T1, T2. We then hit save. It's going to mesh it for us automatically. Polygon mesh options. We just go for the most amount of polygons. We don't care. Unreal Engine will handle a lot of polygons easily. Hit OK. And just give it a second for it to mesh everything for you. The reason why it's taking so long in terms of meshing for me is because I have a lot of detailing going on in the apologies, in the feet of this bench, as well as the connecting dowel joints. So if I were to show you the feet, it's this kind of a screw-in geometry here. And then if I were to show you the dowel joint, let's get it out here, right? It also has some geometry. I think Arctic View might give it a little bit more justice, right? So that's the reason why the export is taking longer. And then for this geometry, this is our scene for like photo studio type of an environment, white box in which the pictures will be taken. This also gets exported. Also needs to be exactly in the same, it uses the 000 coordinates as its starting point, right? For importing. So as long as you don't move things around, they will import into Unreal Engine in the correct place. And I'll just call this scene studio. FBX, perfect. save, and we're good to go. That's it, right? So with that being done, we're kind of done with with exporting for Unreal Engine. One last thing is I probably should talk about the options for FBX that I'm using for exporting, because you couldn't see them because I have this always use these settings tick marked. So in terms of options, we're exporting meshes only. We're not exporting NURBS. That's important. We're also exporting materials as Phong, not exporting any lights, and not exporting any cameras or any views. And I'm mapping Rhino Z to FBX Y so that it doesn't get flipped in an awkward way. Again, FBX really likes to rotate things 90 degrees. So XYZ becomes XZY, right? So with that done, we're good to go. We can export and carry on with our lives. One last thing in terms of exporting that I will cover later on is that there are these plugins that have a live link between Rhino and Unreal Engine. I'm not sure about Blender. Most likely Blender also has them. And you can find them by Googling for Datasmith for Unreal Engine 5. Datasmith. SMITH. Basically, these plugins right here that you see here can export a Datasmith file that has all of the information such as materials, lights, and so on that is needed, and can construct a scene in much more seamless way than just exporting it as an FBX. There are drawbacks, and that is the reason why we're currently using FBX rather than the Datasmith. Once we get into exporting the interior scene for placing our object in it, I will talk about more. I'll talk about Datasmith exporting more. Right. So we're now ready to go to our next chapter. Okay. So now with the geometry being exported out, it's time to actually create the Unreal Engine project. To do so, you open up your Epic Games launcher, and here I assume you already have downloaded your newest engine version, Unreal Engine version, which is under Unreal Engine versions. I'm going to be using 5.3.2, which is currently the newest release. I'll click on Launch, which will open up a new window for me. And for this, we need to wait a little bit. There we go. So in this new window, you will have the possibility to either open up your recent projects, if you have any, or use any of the templates that are available for you. So there's the games template, and you can create like first person, third person, top to down games from these. Film, video, event template, architecture, product design, and simulation. Clearly, since we're trying to showcase our product, we're going to be going for the automotive product design and manufacturing template right here. There is a Photo Studio template already available for you, but I strongly suggest you starting from scratch and following along, of course, with this course, starting from scratch so that you know exactly what different things do. And starting from completely empty scene, I believe, is more beneficial than it is to start from something that is already pre-made for you, because you learn more. So we will choose blank instead of Photo Studio. Blank as our template. Automotive product design, blank. Project name, I'll call it YouTube product. This is also, by the way, the Unreal Engine file is also going to be available for the Patreon supporters. Again. And project location, I don't mess with the project location. I hold all of them in my documents folder as per usual. Once you've done that, you're ready to go. You hit create. It's going to compile a bunch of things, and for you it's going to take a little bit longer because it will need to initialize the shaders and so on. Usually it takes around 10 minutes to do, maybe less, 7 minutes or so, since I've already pre-made it, I guess. I've opened it up before, it's already compiled for me. With that being said, the shading is a little bit iffy. Let me check. It's still calculating. Yeah. So you will notice that when you open up Unreal Engine for the first time, Unreal Engine project for the first time, it needs to calculate all of the mesh cards, all of the shadows, and so on. So just give it a second to catch a breath, and once it's done that, then you will be ready to go. Okay, there we go. Seems like we're quite stable. So let's begin by me explaining you the navigation and what you see here in general, right? What is it, how does the UI work in Unreal Engine? And I also believe you will not be seeing neither this, or this. This is going to be a little bit closer to what you see. Right. So Unreal Engine project can contain multiple levels inside of it. So there's the hierarchy. You have a project that contains all of the assets, all of the trees, all of the settings, all of the everything, right? In your that you're going to be using. And inside of that project, you can have multiple levels. Think of it as, like video game levels, literally. Multiple small worlds in which you can construct things from the assets that belong to the project. So for instance, a project can have a blue chair, and you can have 5 different worlds, 5 different levels, and you can use that same blue chair in any one of those 5 levels. Because of this, creating one project that will handle every single product presentation from now on is much more economical, so to say, compared to creating a project per product, right? Because you can just have a level for a chair, a level for a desk, a level for a car, and so on, whatever products you have in the list. I hope that it kind of makes sense. There's a hierarchy to it. So currently, our level name is called main, right? So that's just the level that is created. And this level contains assets, or not assets, but objects that are listed here on the right-hand side in the outliner. So everything that you have here in this main level is listed on the right-hand side. So I can see there's some fog here. If I select the fog, I can tick mark this eye icon, and now fog is gone. So now we can see the void, the black void, the black nothingness underneath. There's the camera actor, this camera right here that is looking at the floor for some reason. Not some reason, because it's waiting for you to give it some geometry to look at. So we can hide that. There's the floor. This guy right here that I can move around. I'll talk about moving a little bit later. That we can hide as well. Instanced foliage actor. That is just the north, east, south, west. Come on. The cross. The reason why it's now glowing like crazy is because it's reflecting the skylight, and it's white, so it's over bright for our camera. And the reason for that is because we turned off the fog. If I turn on the fog again, the camera auto brightness will expose for the fog, thus making this asset not over bright. You're always playing a balance between the camera auto exposure versus how bright different elements in the scene are. So I can hide that. Actually, that's strange that it's not hidden. Is it that? No, it's not that. It's my bad. It's a foliage actor which is not being used right now. So if that is Okay, it's the sun and sky widget rather than the foliage actor widget. So I can hide that, and suddenly sun and sky are gone, only clouds remain, and then I can hide the clouds. There's also player start, which determines where the player will start the game once you press play, which I can actually show you now. In terms of navigation, before we start the game, in terms of navigation, it's WASD to fly around while you're holding the right mouse button down. Right mouse button, hold it down, click and hold, D, A, W, S, Q going down, E going up, and while you're still holding down the right mouse button, look around. So it's different from Rhino or Blender, right? You can still use the scroll wheel to zoom in, zoom out, but trying to drag the view will not work. You do WASD movement just like in a video game. You actually get used to it quite fast, and it's in my opinion, for visualization purposes, it's more superior than Rhino navigation. Of course, for modeling, it's less superior, clearly. Anyway, to actually play this level and see how this level plays, you can press the play button right here. If I play this, bam. Now I am a player. I can't see my feet, but I am a player that can walk around on top of this plate. And I believe I can, no, I can't go through it. There is collision, right? So if I try to pass through it, I can't, there is collision, but at the same time I can fly, right? So I can kind of look around and so on. It's a very simplistic moving mechanism. Once you're done, you just hit escape and you're back to editing view. Okay. With that said, I think further explanation will be done with actually having geometry in, or with kind of using the UI to do something rather than just messing around with messing around with the default map here or default layer here. Let us apologies. Let us create a new level and use that from now on as our starting level. So in the content browser right here, I'll expand this. This is where all of your assets are going to be located. Every single one. By assets, I mean starting from geometry, materials, textures, sounds, fonts for text, behavioral chains, so blueprints, we'll talk about blueprints a lot, user interfaces, levels as well. Like everything is going to be listed here in your content browser and will be accessible from any level. That's the point that I'm trying to get to. So this is an important thing, and I suggest that you, once you've expanded this, you click on this dock in layout, top right corner, dock in layout, and you just dock it to the bottom area of the viewport. I'll show you how it works. If you take it by the name content browser, if you take it and you kind of wiggle it around the screen, you can see that it kind of wants to dock itself to different positions. So we dock it at the bottom, like that, and we minimize it, or not minimize it, but we make it as small as possible. Yay! Okay, now, in this content browser, the first thing that we will create is a few folders. I think it's time to create a few folders that we'll use. So in the content, under content, right? Content folder, here we have our main level and we have our default build or main build data and blank default. We will be deleting this folder later on, but for now we'll keep it. Here I can click anywhere on an empty space here, right click, I'm sorry, not left click, right click, choose new folder, and for instance name it levels, like that, right? So here you can, sorry, I'm just checking if it's possible to, yes, we will be able to set color for different folders. Color coding things is useful. So we have our levels folder now created. I'll create one more and I'll call it geometry. So right click, new folder, geometry. Right, so all of our levels will be here, all of our geometries will be here. Let's do one more, materials. Materials folder, okay. So now on the left hand side, I can right click on my levels folder, rename, or sorry, not rename, set color, and I can set the color of it to, let's say my levels are going to be white colored, like that. My geometry is going to be set color, new color, red. And my materials are going to be blue. New color, blue. There we go. This will, at least for me, just visually, really helps me kind of catch what I'm doing and where do I need to click, right, to get the levels. Oh, sorry, to get the correct assets. So now we double click on the levels folder. We get in here, and here we will create a new level for us that is going to be completely empty. So we start from absolute zero. Right click, level. We create a level inside of our levels folder. We name it, I'll just name it furniture underscore, or furniture T1, T2 without underscore. But you can name it whatever you want, right? Your level name. My first level is fine as well. Hit enter to name it, and that's it. This is now your new level that you have created. Double click it. It's going to ask you to save the changes. Sure, you save everything that you want. And voila. Now you're inside, you have left your standard like base level that this particular blank template comes with, and now you've entered the furniture T1, T2 level. If you want to go back to the base level, you can easily do that by finding it in your content browser. So if I go back to this content folder, here I can see that there's level main, and I can double click it, and now we're back, right? So we can jump between the levels quite easily. I go back to levels, furniture T1, T2, opened up this one. All right, so that's kind of step one. Step two is to actually set up the settings for our level, right? So, no, sorry, not the level, apologies, very important, not the level, the project. The project settings are inherited by every single level in the project. You don't set settings per level, you set settings per project, right? So we will set up those right now. In my here on the top right corner, and it doesn't matter which level I have opened up because it's global, right? So here in the top right corner, I click on settings, project settings. I choose project settings, and it's going to open up this menu for me. These are literally every single kind of setting of the project, right? And you could spend days you know, just kind of going through them and trying to figure out what is it that you want to do. We will be just focusing on the key points, key aspects that we want to change. So description, maps and modes, we'll come back to this a little bit later, or actually, no, right now. Maps and modes, default game mode, this will be changed later, keep that in mind, but for now we leave it as it is. But for the default maps, actually we want the map, the level that we have just created, our own furniture T1, T2 level, to be the main level, right? So when we start our project, it starts. So editor startup map here, I'll click on the main, and here I'll find my furniture T1, T2 as a level, and I select it like that. You can also, by the way, just click and drag it on like that. That works exactly the same way as just selecting it from the list. I prefer dragging. For game default map, we also do the same thing. We drag and drop in our furniture T1, T2. There we go. So now this, according to this setting, every time you start up your project, it's going to load in this level. We go further. Packaging, that's fine. Supported platforms. In terms of supported platforms, you need to choose what is it that you're going to be packaging your project to. You know, what kind of hardware or computers will be able to open your project. And in our case, we're going to go for Windows machines. So I'll untick all platforms and I'll tick everything except Windows. Technically Linux would be also nice, but no, we just go for Windows. Those of you who want to go for iOS, it's trickier than that. I suggest that you Google packaging Unreal Engine 5 projects for iOS. You do need a special license and so on to do so. Windows, anyone can do it. That's why we use this. Okay, next, target hardware. Here, you want to make sure that the quality is the highest possible quality that you can have. So it's desktop, maximum quality. Perfect. We move on. If I keep scrolling here, right at rendering, right here, if I click on this, you can see all of the render settings that the Unreal Engine will use. And the render settings here that we should focus on was going to be global illumination, that needs to be lumen. Reflections needs to be lumen. Lumen is a system that handles both indirect light or light calculation, shadow calculations, as well as reflection calculations. And it's, I mean, compared to every other system, this is the strongest one that Unreal Engine 5 has, and that's what we use. If this wasn't a beginner level course, I would explain more, but in this case, we stick to what I just said. Reflection capture resolution 2048 is a little bit of an overkill, but I think that's going to be fine, so we stick to that. Give me a second, I'm opening up my notes so that we don't forget anything. In terms of Lumen settings themselves, so Lumen has its own settings, of course, as a system. Ray lighting mode, instead of surface cache, we use hit lighting reflections. Those reflections are going to be more accurate than surface cache, but will require stronger hardware. High quality translucency reflections, sure, we can tick mark those. In my experience, does not make a big difference. Software ray tracing mode, detail tracing, global tracing, we use detail tracing, more accurate. Very important that your shadow maps are virtual shadow maps, that your hardware ray tracing is supported, ray traced shadows are supported, you're using texture LODs, and just in case you can use path tracing to just have it as tick marked. I will explain what it does in later stages of this video. Generate mesh distance fields, all of that should be enabled. Nanite, always enabled. Nanite is another system. So all you need to know is Lumen and Nanite, these two systems that are very important. Also substrate, but that's materials. Lumen takes care of light in a very accurate way. Nanite takes care of very heavy meshes and remeshes them or reduces their polygon count according to how many pixels are used to show them on the screen. Meaning, if the mesh is further out, Nanite will remesh it, will reduce the polygon count more and more the further it is away from the camera on the screen. It's magic. It works very, very well and enables you to have billions of polygons on the scene without crashing your computer. All right. Then in terms of static lighting, we will not be using any static lights. Static lights require you to build them, basically for the computer to calculate, for Unreal Engine to calculate their position and how they're bouncing around, and the moment you move them or you change something, they need to be recalculated. We will not be using them. So I'll be unticking allow static lighting. This triggers, you can see, this triggers restart now button right here. I will be clicking that once we're done with the settings. So what else is there? 1 second. Forward shading, we don't mess with that. Translucency, no, that's VR. This is not a VR course. We don't we don't change anything there. And then materials. Okay, so there is an old material system or a new material system called substrate. By the way, if you're having trouble finding things that I'm talking about, you can just type in the keywords that I'm using to describe an option. For instance, substrate. Substrate. So this is a new material system that is introduced with Rhino 5.1 or 5, Rhino 5, that is going to replace the old material system. So it makes sense for me to do this tutorial with it. Currently it's still experimental, but it seems to be stable enough for me to show the whole process by using the system. So I will tick mark substrate materials experimental. It gives me a warning that it's experimental. I hit OK. And we tick mark the substrate opaque material refraction. I will not be, actually, 1 second. Advanced visualization shaders. Enable advanced substrate material debug visualization shaders. Base path shaders can output such advanced data. I will tick mark this as well. This will make the rendering slower and allocate more memory. Please do not check in. Instead, you could add. Okay. So this just says that this is an overkill and you shouldn't do it. That's why I was on the edge. We will not be using the substrate advanced visualization shaders. We'll have this unticked. We're almost there, I promise. Now if I keep scrolling through the settings on the left hand side, and let's escape out from or close down the substrate search. If I keep scrolling down, platforms, Windows. So we'll be changing a few things, or rather checking a few things for the Windows platform for which we're going to be publishing this. D3, D12 targeted shader formats should be SM6. That will give you most stable results. D3, D11, SM5, that's correct. Vulkan target, we don't use Vulkan, that's so whatever. Default RHI should be DirectX 12, the newest one. We use D3, D12 here, and we will be using DirectX 12. Scrolling down here, nothing we need to change here. Okay, that's it. Now we have all of the settings, all of the global project settings done, and we have a new map done, and we need to restart the project. This is still complaining underneath, you can see it's still complaining. I will be clicking this restart button, and once it has restarted, then we will move on to our next chapter. So let's go for it. Alright, so now with the project set up and ready to go, it's time to import our geometries that we are going to be presenting. So before we begin, actually in the geometries folder, I'm going to create a few more folders so that we have a proper structure. It's very important to have a proper structure within your assets so that you can later find what you're looking for. I'll create a new folder, right click, new folder, and I'll call this furniture, because that's what I'm showcasing here. This applies to any geometry that you would like to showcase. So if you have cars, you name this cars, right? And then I'll create another folder and I'll just call it supplementary or other. Other is fine, right? And in the furniture folder, I'll expand this or open this up. I'll create a new folder and I'll call this the name of the furniture piece that I'll be showcasing, which is T2T1 or T1T2. Oh no, T1T2 in my case, right? You can call it any, let's keep it simple. Let's call it desk, or this is not a desk, this is like seating, easier. Okay, open that one up, and this is where we're going to be importing our FBX files. So if I were to open our folder to which we've exported the FBX files in the previous chapters, we see here two folders named export from Blender, export from Rhino. Export from Rhino is the one that I'm going to be using, but just to be kind of clear, the process of importing is going to be exactly the same. So you can see T1T2 blender.fbx is here, and in Rhino we have T1T2.fbx for the table or seating furniture, and scene studio.fbx for the surrounding environment, right? So how do you import? Well, you drag and drop, select the file T1T2.fbx, drag and drop it in here into the geometry furniture seating folder. Here we are then presented with a bunch of settings, and this does not look that bad until you realize that there's also advanced settings, and you can expand these, right? In terms of the settings that you use to import, it's only a few things that you need to change. Build nanite should be turned on. This will enable the geometry to be dynamically refreshed when you're moving away from it or when you're moving closer to it. So it's going to change the amount of polygons of your geometry. I already talked about the nanite in a previous chapter, so I'll skip over it. Generate collisions, we don't care about that. We're going to do a different thing with this, so it doesn't matter if it's on or off. Most importantly, we will go to advanced settings right here, and we will make sure that combine meshes is not turned on, meaning that every part of the FBX model that is imported imports as a separate entity, as a separate object. That is a very important thing, right? Because you will want to have them exploded later on in an exploded view. Besides that, let me just kind of quickly go through here. Of course, you can change where it's going to be positioned and what's its original rotation. You can force, I'm trying to see Blender, it's not Blender, you can force Unreal Engine to read what are the units that were used to generate the FBX export and then convert them into centimeters. Most of the time works, sometimes doesn't. That's the reason why I have this unticked by default. But if you're trusting in your nature, you can have this tick marked, and most of the time it's going to work. Besides that, it's pretty straightforward. We just import all. So the only thing is build nanite and combine meshes turned off. Import all. We give it a little bit of a moment. We give it a moment. It's in total is going to be 39, 41. What are those? Those are not just the geometry bits, but that's also the textures, the materials, and so on. All of it, right? And here, after it's imported, you can see all of these different, well, these are not errors, these are warnings. Yellow is warning, red is error. So warnings, which says mostly that we have a lot of, or not a lot of, but some very small edges in our exported meshes. And that makes sense because these are transferred from NURBS geometry into mesh geometry, meaning, yeah, sometimes it will make a very short edge. That is not an issue, honestly. The degenerate tangent basis might be an issue, but we will need to check that to see, like, if we visually can see that the shading is weird, then we will know at least that object 4 needs to be fixed in the 3D modeling software to solve that. Besides that, this is fine. I clear this, I close this, and now we have a bunch of objects right here. So what we have here are every single part, every single piece, and I can double click on any one of them to actually see it, and it's very hard to see it. So here in the top, until instead of clear sky, we expand this and we choose neutral shared, neutral background, so that the HDRI is not, the HDRI that is used is not too dark, I guess, or it's shading properly, because there are issues with ray traced HDRI maps. Doesn't matter. Neutral shared will show you the form. You can see that it's completely black, and it's very hard to understand what is it that that we're looking at. I know that these are the feet of the table, but we need to change the material of it. And honestly, instead of switching up the material, I'll close that. I will change the material itself. I'll try to investigate why the hell is it that this material is black, completely black. We will have a separate, I double clicked on it, by the way. We will have a separate tutorial on, oh, that looks fine here. We will have a separate tutorial on materials within this course in later chapters, so look out for that. In this case, I'm not going to show as much. So the shading was actually fixed, the material was fixed by me just simply restarting Unreal Engine and letting it recalculate the material itself. That's all it took. If you're still having troubles with material showing up as black after the restart of Unreal Engine, then double click on the material here, untick cast ray traced shadows right here. I'll explain that again in future chapters. Untick that, hit save right here, so that it kind of triggers an update. Tick mark cast ray traced shadows again, and hit save again. So you're basically triggering a recalculation of the material, which seems to be forcing like proper wrapping and then like proper what's the name, representation on the viewport at least. Okay, With that being done, it's time to actually get all of these parts into our scene. So if I select all of my elements here, holding down the Shift key, just don't select the texture nor the material, just the parts. Holding the Shift key, first one, Shift, click, holding Shift key, click the last one, select all of them, and I drag all of them in, just like that. Bam. Now, my geometry is located in the world. And it's completely black because you can't, there's no light, right? It's only, you can see here, it's only the geometry that is created, right? And I have all of it selected as well. I will be, apologies. I will be positioning it so you can move it around like that with the moving axes. That's the shortcut for the move tool is the W key. E key is rotation, right? And R key is scale. Don't scale it and don't rotate it, but you can move it around anywhere you want. Right now it's arbitrary because there's nothing in the scene, so it's all relative, except for its relation to the world 0, 0, 0 coordinate. If you still have all of these elements selected, if you don't, then you can just simply select the first element in the list here in your outliner, scroll down to the end of the list, holding the Shift key, select the last element in the list, and now you have all of them selected. You can reset all of their locations to fit on right on 0, 0, 0, right? So you're moving them back to 0, 0, 0 by simply clicking this little arrow right here. Bam, you can see it's now zeroed out. You can also click that one. You're basically resetting the location to the origin. And now it's here. With that being said, now it's time for me to explain to you the difference between the elements that you see here, listed here, right? And the elements that we have here in the content browser. These are not the same. Those of you who are familiar with linking, for instance, Adobe InDesign links a file. So there is a file somewhere on your hard disk, and Adobe InDesign creates a link to that file as a reference that it represents, that it shows. That is exactly what's happening with the outliner here. Meaning that all of these assets that are imported into your project don't get duplicated every time you duplicate assets in your viewport, in your scene. Actually, I'm going to switch this to wireframe so that you can at least see the model. So here in the top left corner, instead of lit, I'm going to choose wireframe. There we go. So these assets right here are references. These forms right here are references to the original assets that you have imported into your Unreal Engine project, right? This just makes it much more lightweight the moment you start copying assets, because all they need to do is link to the same asset, right? So if you have a million screws and there's all of the screws have the same form, it makes sense to just have the form and then have million kind of references to that form rather than creating copies of the form itself. Think of it, again, links in Adobe InDesign, or blocks in AutoCAD, blocks in Rhino, right? That kind of a workflow. Very, very effective, very efficient way. Which also means that any changes that you make here in the content browser will be applied to every instance of these assets in your viewport in any level where they are used, right? So these are like global settings. While any changes that you make, by selecting the asset in the viewport under here will be applied to that asset locally, right? Just in that level, just for that particular asset. And of course the options change, or rather you have different sets of options for both. Right. What kind of changes do we need to make? I think right now, none. Let's, so that you don't get overwhelmed, let's first figure out the light, and then we will continue on from there. Before we do so, before we jump to the apologies, before we jump to the light chapter, there's two things that I want to first of all show and then do. First, to show, I want to show the nanite in action. So if I let's make the camera speed slower. Camera speed controls are right here in the top right corner. You can make it go fast or you can make it go slow. Usually with furniture sized pieces, I do 0.1 speed, right? You can see that if I look at this object right now, this is the amount of polygons that I can see in wireframe view. And if I zoom out, you can see that the amount of polygons starts changing dramatically, right? Let me zoom in, right? So it updates the polygons for me. I wonder why the hell this one is not updating. What's up with that? Object 4. Wait, object 4. That reminds me. We already had a warning for object 4. So it seems like object 4 is a little bit iffy in terms of nanite. That's not that big of a deal because that's not too many polygons in total. But if you want it to be clean, then probably you would need to look into why object 4 is different from object 5 in the Rhino file and kind of rebuild it from there. Not the course for that, so we're going to stick to what it is, right? But you can see the nanite working and remeshing our file in real time the moment we zoom out. We will dial in the settings for it at later stages. So that's what I wanted to show. What I want to do is actually in my materials folder right here, I want to create a new folder and I call it masters or master material. Then I create new folder, call it instance. And I create a third folder and call it other. Just other materials, right? And then also we need one more folder here called textures, images, right? So new folder, I'll call it textures. There we go. Then from my geometry, furniture seating, I will take my blue texture right here that I use for the bench, right, to see the tiling or how the edges flow, and I'll drag it into the textures folder right here. And I'll just choose move. I'll take my custom material and I'll drag it to other materials, other folder right here. It's a temporary material, so we don't need it to be under masters. We'll just have them here, right? Just so that the seating folder under furniture only has what's the word? Only has geometries in it. And also I will set the colors to red for furniture seating, right? And also for other. And I will change the geometries for material. I kind of want to do it all at once, so I'll see if it's possible. Doesn't look, maybe. Right click, set color, blue. Nope. Okay, we set it one by one for these. There we go. That's done. And then for other, within the other folder under geometry, I'll go to my exports and my scene studio.fbx. I'll drag and drop it in. Same settings, exactly as what we used. Import all. Smoothing grouping for no, that's fine. We have our scene studio. This one is black again. Let's see. Should it be black? No, it should be white. So it's not calculating. Let's see if the trick with cast ray traced shadows, if turning that off, saving this, if that trick actually triggers. Yes, it does. You can see now it's white. Now turning this on again. Save that. This will force white material to appear. Then I drag and drop in this my studio. I believe it's very far away. Yes. So I reset its values. You can see that's why it looks so small. I reset its values to 0, 0, 0. And now we're good to go. We're ready to go. And now you can even see the nanite in action even better. Right? All right. Time for the next chapter. Let's go. So when it comes down to creating lights, it's pretty straightforward. First of all, lights are not assets as per you can have them in your content browser. Technically, there are ways with actors and blueprints of how to have lights as assets in your content browser, but technically they are created per level as geometry that exists in the level. And let's do so. I'll guide you through this. So anything that you want to create in a level in real time is created through this button right here. Quickly add to the project. We expand this button or click this button to expand the menu. And as we're looking through all of these settings, you can see here lights, right? There's also basic shapes where you can, shapes where you can add a cube, a sphere, and so on. But right now we're focusing on lights. Focus up. There's direction light, point light, spotlight, rectangular light, skylight, HDRI backdrop, and sun and sky system, right? In this case, we're going to be using, well, let's start with point light, actually. That's the simplest one, right? A single point. Point light, bam, there it is. Now you can't see it in action because everything is shown in the wireframe view, right? So I'll click on wireframe and I'll choose lit again. Bam. And now there's light. There are issues. I can see them. Don't worry. I can see the issues. We will fix the issues. So issue number 1 is this area here is indeed glitching out. Don't you worry. We will. I have a solution. I have a solution. Issue number 2 is all of these ugly shadows. Okay, this is actually very important. Since we're using ray tracing in our project, the shadows are ray traced from the light. And also, since we're using nanite in the project, the shape is being constantly remeshed. To battle the flickering of the shape kind of constantly changing the form, the light is actually calculated according to the lowest resolution mesh that nanite provides. And because of that, these shadows are, not accurate, and they're kind of intersect with the shape itself. It's pretty hard to explain it, but I wonder if it's possible with detail lighting. No, unfortunately we don't have any tools to represent this properly, so you'll have to trust me on that. Nanite and ray traced shadows don't work that well together, but there is a way of how to fix it, and that is by making nanite calculate the remeshing more accurately. So to fix the backdrop, I will double click on our Scene Studio asset, right? Not here, not in our level, but globally. So in our content browser, double click to open the asset itself, right? Here it is. And you can see that there's same issues that are happening here as well, right? Exactly same problems. So to fix that, I will go into Nanite settings on the right hand side right here. And here where it says fallback target, instead of automatic, we can't trust automatic, we'll expand and we'll say relative error. So how much of an error can it make when it's remeshing? And we will say no, the relative error during remesh, reduction of polygons, needs to be 0. You should not make an error. We click save. Or sorry, we forgot to apply the changes. You click apply changes, save, and now it's clean. It's good to go, right? We also need to do exactly the same thing with our table. And with that being said, also this area right here, this geometry is messed up. Let me show you a trick of how you can fix it without actually re-importing or fixing it in Rhino. Since I know that this piece of geometry right here is clean and this one is not, I can just simply delete it, delete that one from the scene. I can select this one, and since I've exported everything centered around 0, 0, 0 coordinate, and this is a symmetrical design, I can just simply make a copy of this. Holding down the Alt key, I will drag it up like that. Make a copy of this. And for its scale in the Y direction, I will give it -1. And then I will drag it down. It snaps to 10 centimeter interval, so it's easy to drag, but also you can change its location, right? So I deleted the faulty one, I copied the correct one, and I mirrored it into the correct position. And now we're good. With that being done, we also want to go to the seating and we want to change the behavior of the shadows for all of these geometries. Because if I were to zoom in closer, is there like anywhere where we can kind of see it happening? Come on. Yeah, you can kind of see it there. I'm not sure if this is picking it up, but there are shadowing artifacts, the similar ones to what we saw here on the legs, on any rounded piece of geometry, honestly. So we need to fix that. To fix that, well, you could open up every single piece individually and, go to relative error and change the relative error to 0, but that would take too long. So instead, we will select all of the objects here in our asset editor. We will right-click all of them, right-click, go to Asset Actions, and we will choose Edit Selection in Property Matrix. This opens up a window where you can edit the settings for all of these simultaneously at the same time. So here all I need to do is just search for Nanite. No, we don't search for Nanite. We'll just go to Nanite settings here. It's literally right here. Nanite settings, fallback target, relative error. It's thinking. There we go. Fallback percent triangles, or sorry, fallback relative error, not percent triangles. The relative error is what we're changing to 0. There we go. Bam, that's done. Click save, close, we're good to go. Now this is going to be shading accurately. It's going to cost a little bit extra, but it's going to be accurate. Back to lights. So in terms of, now we fix the shadows, right? So now we can experiment with the lights. In terms of the lights, it's very, very simple to work with. You can see the point light literally has all of the settings right here that I'm currently blocking with my face. All of the settings when you select the light are on the right hand side. Actually, for any object, they're on the right hand side. And here we have the intensity in candelas. It doesn't matter what kind of intensity you will use, even if I use like 5000. The camera exposure will expose for the correct intensity because it automatically exposes, right? So going back to 8 and waiting for the camera to re-expose it is absolutely fine. In terms of light color, I strongly suggest not using light color, but rather using temperature of the light, tick marking that, and then going colder or warmer according to your needs. Don't go beyond 3800, don't go lower than that, don't go higher than 11,200, I believe. No, sorry, that was too much. 9,200, was it? Something like that. Yeah, not 11,000, 9,200, right? Everything out of these values, outside of this value range is unnatural. So for temperature, I'm just going to use 6,500. 5,600 actually. A little bit warmer, right? So also you get the nice bloom effects. We will talk about those a little bit later. All right, so this is boring. Like a single point light is boring, and in terms of lighting your scene, that is not good enough. Photo ateliers don't use that, so we delete it. Instead, photo ateliers use, where is it? Rectangular lights. They use the soft boxes, and rectangular light is like a soft box, right? So that's the one that we're going to be using. Spotlight, I will cover that a little bit later, but basically Spotlight works exactly like a, let's drag it in here. There we go. Yeah, exactly like you would expect. It has a direction and it shines the light. Easy peasy, right? And with, don't forget WER to rotate and change directions. By the way, if you want to focus on a certain piece of geometry, you press F key. You select something in the scene, you press F, that's focus. So your camera will focus on that particular object. Right, so spotlight, no. Back to creating lights, rectangular light, right here. We have no idea where the hell it was created, so I will just look at its transform, its location. And I can see this location is way off, so I'll just going to reset it to 000 so that it's easy for me to fish it out and use W key to move it up, and here it is, right? So as you can see, the rectangular light has its own, shape, and that it always goes 180 degrees. There are ways of how to control that. I'll explain those in a little bit, but basically that's how it works. Let's position the rectangular light in some a little bit nicer way, because right now it's just right in the middle of our, also it's still making a little bit of a mess right there by directly shining it on the surface. We don't care. We hit E key and we rotate it, something like that, something like so. We hit W key, we move it back, move it in right like that. I think that might do the trick. Maybe a little bit further out, E key again, to rotate it, something like so, a little bit higher. So I'm trying to find the key light, the main light source for this bench. Remember the name, it's bench, right? Then instead of candelas, I prefer using lumens. So for its intensity, I'll change from candelas to lumens. And it says 25 lumens. No, we don't use 25. It's 1200. 1200 lumens will do the trick. Seems like the shading is also fixed by an appropriate amount of lumens. Then in terms of the size, source width, source height, let's think. So this is in centimeters, right? So let's say the height of it is going to be a little bit higher than a human. 2.2 meters, 220. Yeah, that's pretty big. That should be good. That seems good. And then its width should be 120, something like that. Maybe 100. It's a little bit too soft. The bigger it is, you can see, the softer the shadow becomes, right? That's important. And as we move in to look at the shadow, you can see that the shadow quality is actually pretty good. I messed up the attenuation radius, I'm sorry. We'll get to that. So the width is again 120, source height 220. Seems to be doing just fine in terms of, you know, creating a soft lighting scenario with a softbox type of a light. Let's move it back as well, just a little bit. Then you already saw me messing around with attenuation. Oh, now we're back to the shading being all weird. So strange. Anyway, you saw me messing around with the attenuation radius. So if we decrease attenuation, this you can clearly see what's happening, right? It's only calculating inside of this sphere that's around the light. So we can control how far does the light influence as it's being calculated. I'll go for like 2000 centimeters, which is 20 meters, so that it calculates everywhere, definitely in our scene. Then in terms of barn door angle and barn door length, you can see that if I change the angle, we can focus in the light more or less, right? In terms of the length, we can make it right into this kind of a, what's the correct word? Oh, camera is having troubles. Come on, you can do it. There we go, exposed properly. We can make this into a very, very specific scenario in terms of lighting. Damn, camera is just losing its mind. Let's not. So the length needs to be a little bit less, right? Less focused. So we're not using a laser for it. And I'll open it up a little bit more, maybe to something like 60 degrees and barn door length 20. Okay, that's done. Let's make two more lights. We'll change the colors later. Alt key, move it in, move it to the side, reset the rotation of the copied light. Again, I copy it with using Alt key, holding down the Alt key and just moving it to the side in the viewport. Like that. And let's, I think we should make it smaller. Yeah, this one should be like 80 by 120. This is a secondary light, right? So we make it smaller. I will E key. I'll rotate it, something like so. Yeah, I should do the trick. And then drag it in. Just trying to find like a nice placement of this. Yeah, something like that. Seems to be quite lovely. Okay, great. So we have that set up. One last light is going to be right at the top. So again, Alt copy, reset everything actually. Move it to the top, E key to rotate 90 degrees, going up. And this one should be big, so again 120 to 220 with no bar door angle or length, so that it just kind of floods the space completely. Or actually it creates this kind of ugly seam, so let's actually have a little bit of a length here with a little bit of an angle here. Yeah, something like that. That should be fine. Okay. So that's the scene. That's how it looks like. I don't like those streaks. Yeah, seems like that's nanite being nanite. As we are moving away, it's still making a mistake. Let's see if we can actually fix it. So how do you, by the way, a quick little tip, to easily navigate to the object that you have in the scene in your content browser, you select the object and then on the right hand side, you click on this little folder with a magnifying glass icon here. Pop. And it shows it in the scene. Double click on it. Okay, so relative error, trim relative error, keep triangle percentage. Everything seems to be very, very nice. Maybe we turned off nanite for this one because it's a single piece of geometry that is never going to be moved. No, we keep it. We'll fix it with certain commands later on. That's going to be a good opportunity for me to show off a few special commands for you. So those are lights. In terms of the temperature, I believe we don't mess with the temperature. Also, I want this to be a little bit closer in, like that. I will not mess with the temperature right now because you change the light temperature after you've applied the correct material so that it plays with the material nicely, right? Without the temperature, without the material, you're flying blind. In terms of other lighting scenarios or lighting types, you can always choose. By the way, I have a whole course on architectural visualization for Unreal Engine 5. I'll leave a link to it in the video description below, where you can learn about the lighting system that is used for architectural visualization. Completely different from this one. But in terms of product visualization, I think, for studio lighting, this is good. For something a little bit more natural, you could use HDRI backdrop. So let me show you this. I just created the HDRI backdrop. We move it down. Right now our lights are way too bright, but you get what I mean, right? So you use this. Let me delete that. I don't want it there. What else? Let's see. No, that's it. In terms of the lights, it's a very simple system. That's it. That's all we want. Let's move on to the next chapter. All right, it's time for materials. So there are two ways of how you can get materials for your Unreal Engine project, Unreal Engine 5 project. One of them being the Quixel Bridge library, Quixel Megascans library that you get through the Quixel Bridge plugin add-on that comes together with Unreal Engine 5. Second one being you download the textures and create a material by yourself in Unreal Engine 5. I will of course cover both of those in this video. So we'll start with the Quixel Bridge because that's the easiest way to work, and that's the go-to, right? So if you go here to quickly add to the project button right here, you can see that there's Quixel Bridge option right here. You click that. Bam. It will open up a new tab for you. The tab might be, there we go. The tab might be just kind of free floating up here. I like to just dock it right next to my level tab so that I have both of them here. You can also dock it right next to your viewport tab right here. Doesn't really matter. Come on. Takes a while. There we go. So after it's docked, you can scroll down. You will need to log in. So here you just choose sign in, and you will use your Unreal Engine or Epic Games account to log in to Quixel Bridge. From there on out, every asset that you download is free, which is nice. So it has both 3D assets, where you can get a bunch of like nice rocks and then stones and branches and twigs and so on. Very nice. And also it has surfaces. There's plants as well, but surfaces, right? Surfaces are the the materials that you can download. So let's get a nice, what do we want? Well, we want like a nice wood material, right? So I'm going to go in here, I'll choose wood, and we will be using veneer. And here you can see the tick marks for the materials that I have already downloaded. And I think this time I will use ash veneer, because in the example file I used oak veneer. I'll use ash veneer this time. There we go. Seems to be quite bright, quite nice. Once you select it, you can see its size 2 by 4 meters. That is going to be important once we deal with the scale of it. And then so that we know that it has to be scaled 2 times in one direction compared to the other, right? The proportion matters. And then here we have the quality, either medium, high, or highest. In this case, I'm going to choose high quality. Almost never do I need to download highest quality materials. Those are 8K. 8K is extremely heavy for your scene, and the scene will just kind of, if you have everything at 8K, you need to have an insane graphics card to be able to operate with that. So 4K is more than enough. Typically you operate between 2K and 4K. Once this is downloaded, I will click on this add button, and it's going to create 2 folders for me, 2 extra folders for me. One called Megascans, the other one called Megascans presets. In terms of Megascans presets, we don't really touch this. This is where all of the kind of underlying functionality lies instead, or master materials and so on, but instead we will focus on the Megascans. Megascans folder, right? Which has our ash veneer right here, right? With its 3 textures. Here in the top, I'll go back to my viewport 1 and I'll just try to apply ash veneer to one of the geometries. And you can do that multiple ways, but the easiest one is to select the geometry that you want to apply the material to, and just drag the material into this slot on the right hand side. I believe you can also drag it just directly on top of the geometry. Yes, you can. Give it a second to recalculate. There we go. And now we have our ash veneer set up here in a very ugly tiling way. That's fine. We will fix this very, very easily. So to fix the tiling, we need to access the settings of the material itself, because remember the UVs of this shape are already unwrapped, meaning that you can't really mess with the UVs as much, but you can mess with the shape we can mess with the material. So I double click on my ash veneer material instance right here, and I can go to tiling and offset, tick mark this, expand it, and here I see how many times does it repeat in X direction and in Y direction. And I remember that it's 2 by 4, I believe, right? 1 second. Yes, 2 by 4 meters. So its X direction needs to be 2 times smaller than its Y direction. So I'll start by cutting it in half and then in half again, 0.25 and 0.5 here. Let's take a look. Seems to be pretty close to correct scale. It's still, you know, not the best in terms of tiling. Now I know why I didn't use ash veneer, but hey, it's getting there. And then, of course, the rotation of this is also wrong. So for rotation angle, I'll tick mark this and I'll choose, if it's 1, it's 360 degrees, 0.5, 180 degrees, so 0.25 for 90 degree angle. And now it's starting to look a little bit better, right? Slowly but surely, it's getting there. So with that done, we can save this material texture. I'll change this to neutral so that we can actually see it. No, we can't. What the hell is going on with the previews and the new versions? I don't know. Doesn't matter. Doesn't matter. As long as we can see it here, we're fine. So that is how we can then apply this material to here, to the legs, and so on. With that being said, for instance, if I want this material to be rotated on this for this leg, right, I need to have a copy of the material with rotation set to be a different number, which is fine. But that kind of brings us to the second part of this chapter. Let's just go with the second chapter of creating custom materials. So let's go to chapter 6, I believe. Alright, so now in this chapter it's time for me to show you how you can create your own materials, which will give you much more insight to the downloaded or the materials that you use from Quixel Megascans. They kind of go hand in hand, so it's important for me to explain both in tandem. That's why I'm kind of confusing between the two chapters. With that being said, first let's talk about where can you get the textures for your materials from. And that is, of course, the internet, but there are two main websites that I could suggest. First one is called polyhaven.com/texture/wood, but basically polyhaven.com, where you can get all of the different textures here, and you can find like very nice, in this case wood, let's go for clean, or rather indoor man-made laminate floor, right? Pretty nice texture with a bunch of different assets. Here on the right hand side, you will see the different resolutions at which you can download these textures. Should it be zipped or a Blender file or anything like that? Of course, it should be just zipped, and you want it to be kind of just handed over to you, and then you just click download and you get it, right? So that's how Polyhaven works. Great resource. Second one is Polygon. You do need to register for Polygon. Not every single material is free, but some are, and out of the free ones, for instance this one, you can see that I have already downloaded it. It's great, right? It's a great texture, and it looks great on furniture, so that's the one that I got. In Polygon, you can choose the resolution, you can choose the workflow. Is it metalness or specular? Unreal Engine uses metalness, so it's better if you have it set to metalness. If you still use specular, that's fine as well. They can be converted to specular materials, not a problem. specular materials can be used in Unreal Engine through conversion. That's not a problem. And then here it shows what kind of maps you're gonna get. In this case, we don't even need displacement maps, but we're gonna get them anyway. And you just click download. I have already downloaded particularly actually this material, which is coincidence, I guess. Under wood, veneer, white oak. There we go, this material right here. And it comes with, let me close that. It comes with all of these different textures. Metalness, AO, ambient occlusion, color information, displacement 16-bit, so more accurate displacement, metalness, so how metallic an object is, normal maps, and roughness maps, right? So clearly some are more important than the others, just looking at the size of the images here, but we will be importing all of them and just choosing the ones that we need. So under my materials folder, which is blue, under textures, I'm just going to right click and create a new folder, and I'll call it veneer oak. Yeah, that's good enough. Veneer oak, double click on that. That's my veneer oak texture. And I will just select all of these JPEGs and PNGs right here, and drag and drop them in. Just like that. Easy as that. I just hit OK to whatever that was. And we're ready to go with creating a material from this. So you need to understand the system of materials in Unreal Engine 5. The system is as follows. There is a master material, basically a function from which you can derive all supplementary, or not supplementary, but derived material, so all instances. So for example, you can have a color master material that has a color set as a variable, and then from that material that has color set as something that can change, you can derive red color material, you can derive blue color material, green color material, and so on. So for materials that use textures, you can create a master material that has all of the textures set to be variables, right? And then in real time, you can switch up the textures and thus creating instances of that master material. I'm not sure if this is making any sense at all, but hopefully once we start building it up, it's going to make sense. So in my materials folder, under master material, I'm going to double click, and here I'm going to create a new material. Right click, material, right here. And I'm going to call it textures. Or actually, let's do a simple one. Let's do colors. Colors. So that everyone's on the same page. Colors material. We double click that. This opens up this whole menu with like the not menu, like node list, node viewport, I guess, where we can create different inputs for our material creation. So what you see here is a substrate material system, right? It's node based. It used to be node based as well, but in this case, it applies this more accurate layering of different textures to achieve a much more precise result compared to the old system. That's why it's being upgraded and why it's being used, even though it's unstable. We're not going to be using it in a too complex of a way, just the basics, right? So here, the substrate, you can see it has multiple inputs. The main ones being base color, metallic, again, you can see specular right here, which is nice, but we're not going to be using that. Roughness, normal, emissive color, and opacity. So let's, usually what I like to do is I like to start from, without using the base color. I like to start by messing around with everything else, making sure that it looks natural, you know, the sheen and the bumpiness of it and everything looks nice, and then I add the base color last. So let's start by messing around with the metalness, right? By how metallic the object is. I will create a scalar parameter, or wait, no, let me show you a quick shortcut. You hold down the 1 key on your keyboard, key that number 1, right? Hold it down and click your mouse. It creates a node, right? This node is just a constant value. You can also right click and type in constant and choose it from here, from this list, exactly the same node. You can also drag out from this and type in constant, also to make it already connected, right? It's multiple ways, but the fastest one is holding down the key 1 and clicking your left mouse button. I connect this constant to the metallic, like so. Let me expand this actually, so that you can see better. There we go. 1. Sorry, and I changed it from 0 to 1. Give it a second. And now it's glossy. Or not glossy, now it acts like metal. If I change this back to 0.5, or sorry, to 0, it should be 0. Now it should be metallic. Does not look like it's changing as much though. It is what it is. In terms of roughness, that's the same principle. I change this from, I click 1, I press 1, I click on the viewport, and I connect the value to roughness. Now the value is set to 0. It's going to be perfectly smooth, 0 roughness. And if I make it hyper metallic, yeah, it is metallic. It's just that it does not have anything to reflect. So it's, oh, there we go. If I use the different preview here, you can see how much it actually reflects, right? So let's change this back to 0 from metallic, and this is how it looks like without being metallic, but being fully smooth. If I change this to like 0.2, you'll see that it becomes more and more blurry. 0.5, very blurry. Fully metallic, and 0.5, blurry metal, right? You get the idea. So that's the metallic and roughness. Both of these values, I will set metallic to 0 and roughness to 0.2 as my starting points. Then for base color, it actually cannot be a single number. It needs to be 3 numbers, right? RGB, red, green, blue. So what we will need to create, I'll drag out from base color, from this input here, drag out, and I'll create a vector, constant 3 vector, constant 3 vector. Bam. And here now I can click on this, or double click on this, and choose any color that I want. I'll choose pink. Why not? Hit OK. This does not care one bit that it should be pink. Let me change this to neutral environment, and now it cares. I don't know what's up with the preview. I'm sorry, but I can't control that part. Usually, honestly, I've seen issues with ray traced previews before. Part of the experience, I guess. Anyway, we have ourselves a pink color that is a little bit shiny and not metallic at all. So this is us creating, what's the word? Give me a second. A base material, like a master material from which we will say that the base color, the metalness of it, and the roughness of it should be variables actually. And then any copy of this or any instance of this will be able to change the color, the metalness, and the roughness. So I'll right click on the color input. I'll choose convert to parameter. And I'll call this color. Color. I'll right click on the metallic input on the node that is currently called 0, convert to parameter. I'll call this metalness. And for roughness, convert to parameter, I'll call this rough. There we go. You can also make the maximum of metalness set. You can set it to 1 by you select the node and then you access the settings of the node. And settings of roughness, you can set the maximum to 1 as well, just so that you don't use like 500 roughness. That will make no sense. There's also a emissive color, so you can make your elements shine, but in this case, we're not going to be using that for now. I save this material and I close it. And now I have my colors material right here, right? This is the master material. I can right click on it and I can choose to edit it. Oh, sorry, I can choose to create a material instance. We don't need to edit it anymore. Create material instance. If I make that, I can call this, I'll call this red underscore color. Red color, right? And now if I double click this red color material instance, you can see that the menu is completely different. And it's only these 3 settings that I can change here, right? So I can tick mark metalness and I can mess around with the metalness right here. I can tick mark roughness, change the roughness right here. I can tick mark color and I can change color right here. Right? That it doesn't end here. It's actually even cooler than that. Let me apply it to these 2 areas. Oh, by the way, one thing important. See how my camera is clipping into the geometry when it's close by to the geometry? You can make it not do that by here in the command line writing a very specific command. If you write near clip, you will see a suggestion r.set near clip plane. You click that, then you write spacebar, and let's go for 0.1, which is 1 millimeter, and hit enter. 0.1 for near clip plane means that now the cutting of the geometry will only happen if your camera is closer than 1 millimeter to the object. So you can zoom in much closer for, value, I don't know, for precision, I guess. And now I can take this red color, which is incidentally blue right now, and I can drag and drop it on the 2 sides here that I want to be colored in blue color. I'm sorry that I'm wiggling the screen too much. The camera is too fast. I'll make it even slower. There we go. So now I can see these kind of 2 blue colors right here. If I open up this menu here, or for this material, now I can change the color of it in real time and I can find a color that I like. So I'll go for something like, let's go for darker, 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 something like that. And I can even make it metallic or non-metallic. I can change the roughness of it. So I'll go for 0.15, something like that in terms of roughness. There we go. We have our red color material set up. Now, actually, let's move it to where it belongs, because this is a folder for master materials and this is a material instance. I want it to be in the instance material folder. So I'll just drag and drop it in to instance, move here. Now it's here. I'll make a copy of it, Control C, Control V, and I'll call this light gray color. Double click. Drag and drop it onto the backdrop right here and change the color of it to, well, light gray. So our, wait, how does that work? We go full white and then we mess around with this slider to get like a proper, yeah, that seems to be okay. And its roughness, I want it to be really high. So something like 0.75. And that's it. Now we have ourselves a light gray material as well. Now on to, for now that's enough with the colors, right? I think it proves a point of how this whole thing works. Now it's time to move on to actually working with the textures that we have imported, right? The veneer oak textures that we have here. So under my master material, I'm going to create a new material and I'll call it textured material. Material that uses textures. Open it up. And here for the base color, for the metallic roughness, emissive, no, not emissive, sorry, normal color, we will be using textures, right? And this is going to be opaque, so we're not going to be dealing with opacity right now. So I will go to the textures folder, veneer oak, and the easiest way, I mean, we can always right click and type in texture sample here, select this node, scroll down here, and here we have the texture, and then I can drag and drop in, for instance, the color texture into the texture sample node. Sure, we can do that, but I think a faster way is just to drag and drop in the texture from the asset browser like that. So I'm going to get my base color texture in here. I'm going to get the ambient occlusion color in here, like that. Let's just have it there. That is called displacement 16, displacement, just displacement. We will not be using displacement. That's too heavy, so we skip over that. Metalness, we will be definitely using metalness. Normal map for sure, we'll be using normal map. And that is roughness. Roughness is very important. We'll be using roughness as well. Is that all? That is all. Okay, so we have all of these textures here. Now we need to connect them properly. So ambient occlusion, easy peasy, just connects to ambient occlusion right here. Then the base color, or actually let's connect base color last because I want to see how it's going to work without the base color, you know, once we connect all of these. So let's connect the metalness RGB to metallic right here, just like that. Let's connect the roughness, so roughness goes in here to the roughness input, like that. Oh yeah, you can clearly see that the roughness is yeah, that works nicely. That is starting to look definitely like proper wood texture. And then let's connect the normal map to the normal map input here. Give it some time to calculate it. Can we do clear sky? Maybe that's gonna be nicer. No, clear sky for some reason is acting weird. I know I'm repeating it, but I'm just sad, frustrated about the preview not working properly. Anyway, the neutral preview at least works just fine, and you can see that this definitely looks like a pretty decent wooden texture, even without the color information itself. That is how you know that the geometry that you have, or sorry, the textures that you have are placed correctly and are working correctly. Then I connect the base color. Hopefully it's still gonna look good. Seems like it's still going to look good once it actually loads in. There we go. Nice. So those are our textures, and we have our materials set up. Now we want these guys to be variables, right? Because what if we want to have a different material in the future? I will right click on the texture sample right here, and I'll choose convert to parameter. I'll call this AO, ambient occlusion. Right click on this one, convert to parameter, diffuse. This one, metallic. That's a roughness. And that's gonna be a normal map. There we go, easy peasy. So with that done, we can save this, and you would think that we call it a day, but there is going to be one issue. And I'm going to actually make that mistake, and then we will fix it just to prove, or not to prove, it's going to be a teaching exercise. So I have this master material ready to go, texture material. Copy paste, or sorry, not copy paste, I'm stupid, delete that. Right click, create material instance, right? We're making an instance from it, and I'm going to call it oak veneer, right? I'm going to drag the instance where it belongs to the instance folder, move here. I'll just drag and drop it onto my tabletop. Desktop, not desktop. How is it called? God damn it! Bench, on my bench. And you can see it's kind of okay. I mean, the reflections are really nice and so on. The tiling is wrong though, and I want to change the tiling. How do I change the tiling? Well, if I open up my oak veneer texture, no sliders to change the tiling. That's a problem. We need more variables. We need to somehow control how often do these materials get tiled. So I'll escape out of that, and actually we will go back to our master material, texture materials, like that. And I will, here, for the UVs, that is the tiling, that is what's going to be, what the tiling is going to handle. For the UVs, I will create proper variable that controls the X and the Y, tiling, right? That's the idea, at least. So first thing that we need to do is create a texture coordinate node, which reads the coordinates of the geometry on which you will be applying this material on. That's good. And then we will multiply this coordinate node. Should we multiply it separately or not separately? 1 second, I'm thinking. No, let's keep it simple. Let's multiply it non-separately. So multiply. I drag out from the node, and I just use the multiply icon, or you can type in multiply. And here, this number is going to be the amount of repetitions, right? So this will have to be a variable. So I'm going to click 1 and click the mouse button, or right click constant. Constant also works, that's fine. Connect it here. And for the value, I'm going to say, well, the default value should be 1, it shouldn't change. But this should be a variable, so I'll right click on it, convert to parameter. I'll say tiling x and y. X and y, both, controls both. And then here for this particular node, I will say that the minimum value should be 0, or rather 0.001, very close to 0. And for the maximum value, it shouldn't be larger than 1,000. I think anything larger than 1,000 will be stupid. So we're just giving it hard limits, something like that. So now if I connect this here, 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 here. So we're taking UVs and we're basically multiplying the UVs by a value. And I save this material now. Go back in here. We look at our zoom instance, oak veneer texture, or oak veneer instanced material. Now we have the tick mark for tiling X and Y. I can tick mark that and I can increase it, you know, to make it more aggressive, or decrease it. Right now it's very, the range is very, very high, so it's all over the place. So I'll need to type it in actually. 0.5. 0.25. 0.2. That actually starts looking kinda right, but again, the orientation of it is wrong. So we need to keep creating the master material. Now I need to change the rotation. Okay, sure. We go back to the master material and let me just dog this next to here, so that I have like 3 tabs. My level, my master material, and my instanced material right here. So now we've done this, but I want to also rotate the texture, right? So I will make a custom rotator. I think it should be for texturing, clearly. Texturing, custom rotator. Asks me for UVs. I do have UVs right here. I can connect them. Asks me for a rotation center. So around which point should it rotate the texture? It should be the middle point, right? So we need to give it like 0.5 in X, 0.5 in Y. For this, I will create a constant 2 vector. Constant 2 vector, and the X is going to be 0.5, Y is going to be 0.5. There we go. That's the rotation center. And for the rotation angle, we will be using, oh, it says between 0 and 1. Okay, we will be using another constant node that we connect here. And the value, rather right click on it, convert to parameter, rotation. And the default value should be 0. But the maximum should never go beyond 1, because it's 360 degrees at 1, so it doesn't make sense to keep spinning it more than that. And now we have our rotation values here. And actually, let me, holding the control key, let me disconnect it. I want to, you can hold control key and disconnect the wire. I want to show you one nice trick. So now we want the chain to look like this. First, it multiplies the texture coordinates, and then it rotates them, right? Along the middle point. So to do so, we would need to reconnect everything like the UVs and so on, but it's too many wires. So a faster way is just to hold the Control key, disconnect, and connect it here like that. So you can disconnect a bunch of wires and reconnect it to a different node. I wish Grasshopper and Rhino had that. And then we connect the multiply to the UVs here. Okay, so now our chain is looking like that. Should be nice. I save this. Now Oak Veneer has one more input here, which is called rotation. And if I set it to 0.25, you can see that it rotates 90 degrees. And here it's also rotating 90 degrees. Easy peasy lemon squeezy. Okay, we're almost there with the custom material creation. One last bit is going to be to create material, to create an offset for the materials. And the reason why we need it is because now if I apply the Oak Veneer for this as well, you can see how perfectly mirrored it is, and that is bad. That is not what you want. So what we want to do is we want to have the possibility to offset the material left to right or top to bottom, right? So that it's not mirroring so bad and things are aligning nicely. So for the textured material, we will do one little thing beforehand, and we will just say to this, I want to add something. So I just in between connect this node, and something that I want to add will have two values, X offset and Y offset. So that's just going to be constant. Right click, convert to parameter, X offset. Right click, convert to parameter, Y offset. Default value 0, maximum 1, 0, maximum 1. These two values need to be appended to a same list, so I'm just going to use append. Is it append many? I don't remember. I think it's just append. No, append many. Let's go. Nope, absolutely not. Give me a second. I'm bad at this. Yeah, it's just under math. Append. It should be under math. We use append vector like that. Connect the two and connect the result of append to the addition, right? So we're going to be adding an offset in X and Y and adding that to the texture coordinates right here. With that chain done, we're done with our master material completely. Well, opaque master material. Hit save. Wait for it to calculate. Go back in here. Let's drag out the Oak Veneer. Now we don't need to see the master material anymore. I'm going to close that. Tick mark, X offset, Y offset right here. And as I'm changing those, you can see that they are offsetting properly, right? There's a slight hiccup, a slight issue, and the issue is no matter what I do, it's always going to be incorrect, right? It's always going to offset. It's always going to be mirrored, right? So what this means is that these two instances of geometry need to have two different material instances with different offset values, right? So I'm going to reset the offset values for this initial Oak Veneer to 0, 0, and I'm going to close it. And actually I'm going to rename this to Oak Veneer 1. And I'm going to Ctrl-C, Ctrl-V, copy-paste, and I'll apply Oak Veneer 2 to the other side right here. Double-click on it. And here I'm going to mess around with the offset values so that you can't see. Yeah, I think that looks just fine. Also, we can use 0.75, so it goes in the opposite way. Yeah, something like that. I think that's going to do the trick. Save that. And we have the top of our table. It's either a table or a bench, I am not sure. We have that done. Now it's time to apply more materials right here. This one clearly needs the grain to go in a different direction, so I need one more. Oak veneer 3, double click that, and the grain for this one needs to be rotation 0. Save that. Hello? What the hell? Oh, okay. Did I apply it incorrectly? No, that's fine. So oak veneer 3 now has correct, there we go, correct grain direction. Then for these guys, we do pop. That is actually pretty damn close. Yep, I like the way it looks. And this one, I like the way it looks. Great. So we have this done. Then for the feet, that is actually going to be a color that we're going to be using. So I'm just going to copy paste, and instead of red color, I'm going to use F2. I am going to use white. Or actually, we already have white color here. Why don't we use that one instead? It should be glossy, right? Yeah, white glossy. Like that. Change that to... Never use pure white, by the way. Pure white is bad, so always use light gray when you're creating bright materials. Pure white is a bad idea. Just slap it on. That's it. And there are inside last pieces, these guys that you see here, that require their own material, but that one is going to be actually downloaded from Quixel Megascans library. That is just going to be faster. I'm going to go here to bridge and under wood. Actually, let me go to my local materials, and here I'll find it. Chipboard, I believe. That's the one that I'm using. I hope. I'm going to get chipboard here. Yeah, medium quality. Add it to the project. Remember that we are still using... you can still use Bridge Megascans materials, right? Chipboard. I go back in here to my folders. Under here, I see chipboard. There's the material instance. The master materials of these live in MS presets. We don't touch those. So this chipboard material, I will only be using it for these pins, so I will make it work. Bam. That seems to be too big of a grain, so I'm going to open it up. And for tiling, I'm going to say, nah, let's do 0.3 in terms of tiling. Something like that. That seems to be much more reasonable. Don't really need to change anything more than that. The leg goes back to the original position. Don't forget that reset button. That's a lifesaver. This goes out. We mess around with the pins here. You can also select, holding down the shift key, multiple pins, and you can then drag the material onto the materials slot right here. Bam. Nice. And then I just wonder, Yeah, there's a hole there. Okay, that's good to know. Good to know. And then here I just reset the position of it back to where it was, and we have ourselves a finished textured model, which looks nice and clean and is happy, and we're happy and everyone's happy, and there's a light. Whew, what today? Okay, that's it. For now, I need to take a breather. I will continue this later. For you, it's just going to be the next chapter, right? For me, it's going to be a whole night's sleep. Actually, I have one more in me. Let's do cameras. Once we are done with cameras, then I can rest. So in terms of camera creation and Unreal Engine, that it's pretty straightforward. Here under quickly add to the project, you have your cinematic tab, and under the cinematic tab you have everything that the cameras need. So camera shake, source actor, so you can apply camera shake to your camera, which we will not be using in this particular course. Cinematic camera actor, which is what we're going to be using in this particular course. Camera rig crane, camera rig rail. These two we will replace with our own custom made tool that is going to have more flexibility and will be easier to call to. I'll explain this a little bit later. And then a level sequence actor, we will not need that in this case. So cinema, camera, actor, cinematic camera. If I select it, just plop it in there. You can see it's somewhere there. There we go. Zoom, 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 zoom. And I just position it. You can see that as long as it's selected, we can already see what it sees, right? And there is blurring going on, and there's a lot of different things going on with it. I'll explain that as much as I can actually right now. So first thing that we do is we find a nice position for the camera to be placed in. I'll reset everything, reset the location and the rotation for it. I will rotate it around the Z to 270 degrees, move it up, move it back some more, something like that, and move it a little bit higher up. This seems to be okay. Now, before we start changing any settings of the camera, first thing that I want to do is I want it to focus on the bench that we have. And to make it focus on the bench, there are two things. First one is actual looking at an object, and second one is the blurring, the focus of the lens onto the object, right? So we'll be changing both of those. So step one is here under, as long as you have the camera selected, under current camera settings, look at tracking settings. I'll expand this and I will tick mark. Can you see it well? Hope you can see it. Enable look at tracking. This option right here. I'll enable it. Right now it does not have anything to track, so I have no idea what it's tracking. I assume it's tracking 000, world's 000 position, which is fine, but we need to give it an actor to track. Actor to track. You can choose anything in the scene and it's going to track it, but I think the best way, the best methodology is to actually create a separate object in the scene that the camera should look at, and that object should be called an actor, because actors don't show up when you actually bake or present the scene through the camera. So I'm going to, here in the quickly add to the project tab, I guess, I'm going to click on that and I'll choose basic actor. An actor by itself is just a point in the scene. Let me reset its position. Is just a point in the scene that has a weird icon that you can make the scale of it smaller. So I'm going to say 0.1. Let's go for 0.25, a little bit bigger. And that is going to be an object that this camera tracks. So how do you do that? Well, you select the camera again. You choose actor to track. Select actor in the viewport. You click on this icon right here and you select the actor. And I believe that should be it. No, it's not. Okay, never mind. Pick actor from scene. That's going to be faster. Pick actor from scene. And here, I believe, then I click on, I click on the actor and now it's tracking. So actually to showcase this, I can move this over. And if I move the actor around, you can see the camera is constantly looking at the actor, right? So now I need to see what is it that I want to focus on. What is it that I want this camera to focus on? And for this particular camera, it's the front of the bench, right? And the middle of the bench as well. It's right in the middle in terms of the X on the X-axis, but it's a little bit too high. And the problem is that we have this 10 centimeter snapping turned on. To turn it off, you go here to the top right corner and you click on this grid icon. Enables or disables snapping. By the way, this is for the angles, this is for the movement, right? So I disable this. And now I can drag it freely and I'll just position it right on the edge, somewhere here. Okay. From now on, no matter where I move the camera, it's always going to look at that particular point, which is very nice. Okay, let me reset this to 0 for its X location. And its rotation now doesn't matter because it's always looking at the object. And now let's do another thing. Actually, let me zoom in to here so that you can see the problem. See what the problem is? The problem is called my view is blurred, right? Because I am tracking the point, but I'm not focusing on the point. So you also need to, okay, let's compress this and let's find focus settings, which should be, yeah, it always takes a while. It should be under lens. Lens. Focus, hello? Is it depth of field? No. 1 second, oh my god. Oh, there we go. Lens settings. No. Focus settings. Oh my god, there it is. Instead of manual focus, we will choose tracking. And for tracking focus settings, we will choose actor to track. Is going to be, again, pick actor from scene. Let's go to it, click on it, and now this is always going to be in focus, which means that things that are not it are not going to be in focus, right? They're going to be out of focus. At this point, this view is a little bit too small for my taste, so I want to have a full view of the camera on my full viewport. So I can go here to perspective. Instead of perspective, I can choose cinema camera actor. That's our camera. Click that. So this is what we have. By the way, we are currently piloting the camera. So if I zoom around, or I move around, you can see that the camera is constantly kind of locks into that point, but I am able to move it by just using the WASD keys. Okay, we're getting there. We're getting there. So our look at and our focus is done, which means that now we need to move on to the actual framing and the actual light intensity, blurring intensity, and so on. Let's get up close to here. A little bit too much. Yeah, there we go. So in terms of framing here, we're almost there. I mean, it's pretty close. I can also make it a little bit nicer by going to perspective, and instead of using default viewport, choosing to use cinematic viewport, which immediately jumps away from my camera. God damn it. Cinema camera actor. We're back to it. Right? So this is how it would look like when it's presented in the app. And here I can then start making decisions on the wideness of the shot and so on. In terms of the wideness, I always like to use like actual correct settings that are realistic in the world. So for film back, I will go for a 35mm full aperture lens, like that. That is 3:2, I believe. Either 3:2, yeah, it's 3:2 proportion, right? Then for its, let's expand this sensor. Yeah, we don't mess with the sensor for lens. 4:1000 by 1.2. Yeah, that's all good. But to change the aperture to a wider one, we can do, we can mess around with the squeeze factor, which is basically a crop, if you will, only reversed, right? You're expanding the aperture to the sides. So I'm going to go for 1.66. Not aperture, sorry, the proportion. So I'm going to go for 1.66, which gives me a cinematic lens, which is nice. Then instead, in terms of diaphragm blade count, that is when you get these kind of nice bokeh effects, how many sides will they have? I like 5 or 6. I don't like 7, so I'll go for 5 in this case. I don't think that in this shot we will ever see a bokeh effect, but hey, if we do, then it's gonna be nice. Then, so that's our lens settings, right? Then for our focus settings, we are already set and ready to go. We don't need to do anything here, I believe. 1 second. We actually do. That's my bad. I'm sorry. Current aperture. This dictates how these two numbers actually dictate how close you are zoomed in, or rather, what's the focal length of your lens. So the smaller the number, the more of a fisheye lens you will have. The larger the number, the more of an orthographic lens you will have. And you can clearly see that the blurring also increases in terms of the focal length, right? So it's a balance between these two, because the current aperture, the aperture also can control the blurring, or not can, it does control the blurring. In terms of the aperture, the smallest that you can go realistically is 1.2, this amount of blurring. In terms of the focal length, if you're going for 1.2 aperture, there's no way that your focal length is anything more than 30mm, right? So this, something like that, maybe 40, but nothing more. So I'm going to go for a little bit more realistic view, and I'm going to say my focal length is 60mm, a 60mm camera, which I need to zoom out a little bit to make use of. There we go. And then this is too much blurring, so current aperture 1.8. Yeah, that's much more reasonable, right? Okay, that's that in terms of blurring. Then I don't think we need to change the exposure here. I think the exposure is fine. And honestly, I would suggest not changing anything more in the camera settings themselves. Everything else should be, unless you want to change per camera, settings per camera, then you should. But generally speaking, I would say it's better to have a global setting through the post-process volume that I will cover, I promise, later down the line, rather than per every camera, because it's very easy to lose track of the settings. Okay, with that done, now I will rename the cinema camera actor. I press F2 key, or you can right click on it and choose to rename somewhere here. It should be somewhere here. There's no way that it's not here, right? Alrighty then, so you press F2 and then you can rename it, and I'll name it Cam 1. The actor that it's focusing on, remember this guy, right? The actor that it's focusing on is going to be named, how should I name it? Something simple, like target, right? Caps lock, target 1. Cam 1 and target 1 is right at the bottom, right there in the list. There we go. So we have ourselves a camera setup. We will make more with this, but for now this is good to go. Next up, we're going to make it so that when we press play, the level is shown through this camera. Okay, so now we have ourselves a camera, but there is an issue. The issue is called, when I press play, this is not the camera that I see. You know, this is something else, and if I press WASD, I am able to move around, and it's all a mess, and it's weird, and I don't like it, and this should not be that, right? How do you make the camera your eyes when you press play? Well, you need to define that in a what's called a blueprint system, in the level blueprint. To do so, I'm just going to save this real quick, and I will go, actually let's stop piloting the camera. This is weird that we are constantly piloting it, so I'll go to perspective, and I'll just choose perspective, or you can just click on here, toggle. Or actually, are we still piloting? Yeah, right next to that little camera icon, that was the button that you press to exit the camera piloting mode. So now we're good. We're back to normal, and also instead of cinematic viewport, we'll choose default viewport, so that we can actually see where the camera and the lights are and so on. So to make this camera your active camera, when you press play, you need to do the following. You click on this blueprint icon, I guess, on this icon right next to quickly add to the project. Click on this, and you choose Open Level Blueprint. This is a chain of commands, or nodes, if you will, that run. Let's go for add the start of the level. You can see here, event, begin play. When you press the play button, something should happen in the world, right? Or rather in this particular level. So this open level blueprint opens up the logic of what's happening in the level. We will be not using event tick, which basically triggers something to happen at every millisecond, well, not millisecond, but like every tick of the game, like multiple times per second, because we don't need it. So I'm going to delete this node. But event begin play, when we start the game, that is something that we need to do, right? Or something that we need to use to actually, we start the game. It should fetch this camera, and it should say that from now on, the view should be through this camera. So event begin play. We need to get this camera in here, so I'm just going to position this blueprint like so. I'll select camera 1, and I'll drag it in to the blueprint, like that. This is, by the way, only the level blueprint is where you're able to just drag an object from the level and reference it this way. Other blueprints are not as forgiving. Any object can have a blueprint of its own and have a functionality. That's how you make doors open and lights turn on and so on, right? That's all blueprints or C++ coding. But we don't do that here in this channel. We just do blueprints. All right, so we have camera 1. Then I want to use a command that is called set view. Let's drag from event begin play. Set view with, set view target with blend. And you can see that it's not popping out because it does not register as this command being context sensitive, right? So this tick mark is preventing it from popping in. If I untick this, suddenly you can see it right here, right? So make sure that to untick context sensitive to get the set view target with blend. Bam. We get ourselves this whole damn node here that gets triggered by the event begin play. These triangles and this bright wire means that think of it as electricity almost, right? Impulse. So this triggers when you press the play button, and in turn electricity flows through this wire and triggers this node, and this node starts calculating or doing what it's supposed to do. Once it's finished, then it can trigger further nodes along the chain. That's the way it works, right? In single line fashion. When it crashes, it's kind of easy to find where it crashed. All right. So now the question is, where, we have where should it blend the view towards. That's our camera 1. New view target should be camera 1, just like that. That's easy. The target, who is it that is blending towards that camera? Whose view is it that is blending? Well, that is the player, right? The person who played the game, who's playing the game. So I'll drag out from target self. I'll type in get player controller. Get player controller, just like that. I don't like this. I don't like this target self. I think there should be a better one. Let's try again. Get player controller. Oh yeah, it was under player state. It shouldn't be under player state. Let's keep scrolling until we see. There we go. Game player get player controller. It's this one. I know it's confusing right now with the what's a player controller, what's a player, and so on. I don't know what to tell you. It's going to become easier the more you use it, and the more small bits and pieces of this kind of puzzle you kind of get into your head and start understanding how the system works. At the beginner level course, it's close to impossible for me to kind of cover every single aspect of it. So player controller is basically an entity that controls the WASD keys and is the object that looks at the scene and presents it onto your screen. I guess that's the best way to explain it, at least for me. Then we have a bunch of these other settings here that we don't really care about. Blend time is how long does it take to look through the camera. In our case, it should take 0 seconds. It should be immediately looking through the camera. And function is a straight line, so it is a linear function. I think we're good. Let's compile. You do need to compile it so that it kind of registers the changes and then you save it. We can close it and then we press play. And now when we press play, it's looking through the camera, right? Once we're done, we can press stop simulation and then it's going to stop the game. If you want to open it in a separate browser or a separate window, you can click on these 3 little dots here and you can choose new editor window. Click that and now it's going to, every time you press play, it's going to open up not in the viewport, but rather in the new editor window. That is I find it to be quite useful. If you want the editor window to be a little bit bigger, then you can click these 3 dots again, go to advanced settings. And here for new viewport resolution, you can change the resolution of the viewport to, let's say, 1920 by 1080. Most used resolution out there. Close that, press play again. Now it's a bigger screen. Very nice. Escape closes it, of course. All right, so in terms of the level viewport, I hope, level blueprint, I hope that kind of explains the basics of it, the gist of it. It's something that like a chain of events that happen in the level and that you can use to control different things. Usually it's a good idea to have the level blueprint as clean and as empty as possible. You don't want to bog it down with too much functionality. But stuff like changing the camera and so on, it's fine to have it in the level blueprint. With that being said, now I think we are ready. We're ready to move on to our next chapter, which is going to be, it's going to be a tricky one. That is going to be creating a blueprint that explodes this bench. Should be fun. All right, everyone, good morning. It's time for our chapter 9, in which we're going to take this bench and make it into a system, a blueprint system that is able to be exploded. So you can get an exploded view of the geometry of the bench itself. So every single part is separated. Before we begin, I want to actually address an issue that we had throughout this course with the material preview. In this version of Unreal Engine, it seems like the skylight calculation, so indirect illumination calculations, together with ray traced shadows, seems to be broken, not working. So if I look at my textured material preview right here, you can see how messed up it is. To fix this, we do need to use a command line command. Right here in the bottom, you'll see your command line where you can type in any kind of a function that you want to change within your project. So this is per project, not per level. So hopefully you only need to type this in once. If we will see that it kind of repeats, we will bake it into the project settings by hand. But for now, let's just type it in. R dot ray tracing dot skylight one word, r dot ray tracing dot skylight spacebar 0. Right? Hit enter. And then if I take a look at my material right here, it recalculates into something that is now absolutely fine and absolutely usable, right? So what we did with the 0 at the end of that command line was that we disabled the skylight calculations in ray traced mode, right? Meaning that it would use a more, like, not necessarily older, but a different method for calculating the indirect illumination, thus actually not breaking itself. Okay, that's the workaround, and that's the command that you should use if you're encountering this problem. If not, then hey, good for you. We move on. So in terms of this table right here, all of the parts that we have, or bench, I keep interchanging, furniture piece. In terms of this furniture piece right here, all of the parts that we have are separated out as they should be, but it's very hard to actually animate them. Just a little bit of coffee. If we were to keep them all separated in our scene like that, it's it won't work. So what we need to do is we need to create an actor, a blueprint, if you will, that would take care of that. Remember when we did the level blueprint, which is right here, chain of commands that says when we begin the play, the camera should shift to the eyes. We will create a similar blueprint that exists in the level that will say when we press a button, the bench or the furniture piece should explode, and when you press another button, it should contract, right? That's the hope. Okay, so before we begin, we need to go to our content folder. This is the main folder, and create a new folder called blueprints, or BP. BP. Very useful to have it there. In that blueprint folder, I'm going to open this up, and I'll create a new blueprint class right there. And I'll choose actor because that is like a static object that does not need to have any additional functionality such as a character does. So actor. There we go. And I'll call this T1, T2 because that's the name of my bench. That's what I've decided it is called. I'll double click on this, and I will actually dock it right next to my level. So I'll click on the name here, or name of the tab, and I'll just kind of drag it over next to my level name. There we go. So there are three main tabs inside of this blueprint. There's the viewport tab that contains all of the geometries that the blueprint might have, or not might have, that the blueprint will have. Not just geometries, also all additional stuff, for instance, sound and blah, blah, blah. Then we have the construction script tab right here. This is what happens, what gets triggered even before you begin the game, right? So here you can say that, well, for instance, the construction script can say whatever geometry we have in the viewport should be copied 50 times along the x-axis, blah, 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 blah. So it takes care of that even before the game begins, right? So in your viewport, you would see, let's say, a box. So you would see 50 boxes just kind of copied automatically by the construction script. The event graph is what happens during game runtime. You're already familiar with event begin play. That is a single trigger that happens when you press the play button. So it's excellent for loading in information and for doing something once. Then event actor begin overlap. That happens when the character kind of reaches the object and overlaps with an invisible box next to the object. So imagine you come close to a door and the door automatically opens up in the video game. We will not be using this in our course this time, so I will just delete it. And then we have event tick. This is what happens at every millisecond or kind of sub-second of the game. So if you want something to be triggered constantly, for instance, a character constantly is checking what is the closest box out of a million boxes next to it, and that box is going to be colored red. If you want it to constantly check at every given millisecond of the game, then you use event tick. Because if you use event begin play, the character at the start of the game will only check once, okay, that's the closest box, and then will never check again, right? This happens only once, this happens constantly. We do not need anything to happen constantly. Yeah, there's no need to check for things constantly. We will be triggering explode and construct by the press of a button, so this is not necessary. We delete it. Okay. Back to the viewport, let's construct our table right here and give it like proper colors, not colors, textures, materials. So I'll open up my content browser right here. It's still there, even though when I change tabs, the docked version is hidden, but the below content browser is still there. So, oops. So I open it up. I go to geometry, furniture, seating. Holding the shift key, I select all of the furniture pieces and I just drag them over here to the left-hand side. Bam. My desk is built. Notice that it does not have the wood texture, and also we still have that problem with the texture mapping of this particular piece because the export was broken. That's fine. We will heal it just the way we healed the previous the previous one. 1 second, thinking. Yes, that should work. Yeah, there's no reason why it wouldn't work. So we're just going to delete this one, and we're going to make a copy of our object 1, and I'll just rename this. Instead of object 1, let's call it top 1. Renaming is F2 button. You can also right click and choose rename right here. So top 1, I'll just select it, Ctrl C, Ctrl V to make top 2. And while I still have top 2 selected, here on the right hand side, I will flip it over because again, this is a symmetrical object, right? So I'll flip it over. Oh my God, the camera is way too fast. There we go. I'll flip it over to the other side by giving it a scale of -1. Just like that. You could also rotate it 180 degrees, that would work as well, around the z-axis. Right, so now we have a mirrored version. Okay, now it's time to clean things up actually a little bit, because I don't want everything to be listed, or not listed, sorry. Give me a second. I don't want everything to be just kind of crammed into one list here, because it's going to be hell when I need to figure out which one of these belongs to the legs, which one of these belongs to the feet, and so on. So it's a good idea to either is this crashing? Okay, where were we? It crashed. I had to restart. So we need to make this system, this left-hand side system, a little bit more user-friendly, a little bit more readable. And to do so, I'm going to add a few more components, and I'll parent, so I'll create a hierarchy of these almost, you can think of it as groups. So a group for the top of the desk or of the furniture piece, for the legs, and for the dowels as well, right? So to do so, let's think really quickly. First of all, I need to think how it's going to be exploded. Okay. First of all, let's add the two tops of the desk into one group. And with that being said, I need to make sure that these guys right here, the red pieces, right, are also added to that group so that we can easily move them up and move them to the sides, right? That's the plan. So I'm going to go to the left-hand side here, and I'm going to add a scene. A scene is basically a point around which you can construct a bunch of, or not construct, but to which you can anchor a bunch of other geometry. It's very useful for that. So I'm going to create a scene. I'll name the scene top in caps lock, right? So I have the scene here that is set, that's called top. Now I'll take top 1, which is my top of this plank right here. Top 2, and I'll just drag them on top of top scene. So now we can see that if I select the scene and I start moving it around, both of these geometries that are parented to it are going to be moving with it. This is very helpful later on when we need to model things, or not model things, but when we need to move things as groups. Then I'll select this one, object 6, that is also going to be part of the top. I'll select that one. This is object 5, also part of the top. I could start renaming these, but I think just grouping them up will do just fine. Okay, so top is done. Now I'm going to make another scene, and I'll call this leg or legs 1. Legs 1, right? And for legs 1, which ones do we do? Maybe we do the, let's think. Yeah, let's do the left-hand side first. So these guys right here. So for legs 1, I will connect, of course, the main, and I'll just name it actually, main, or L1 main. L1 main for the main wooden part. And then we will have also the dowels that are inside here. And to find the dowel joints, actually the fastest way is just to skip through. Yeah, there we go. There's one. You can you see it? I hope you can, right? It shows up as orange, right? Like that. So that's going to be dowel 1, and dowel 2 is, I assume, going to be like 15 or something. No, 16, 11, okay. Of course not. It would be too easy. Let's go through. Oh, 13. Okay. Just like that. And that's going to be it for the legs 1. The wooden piece as well as the 2 dowels right here. Then we do exactly the same thing on the opposite side. Add scene, legs 2. And I'm recording this and I'm showing this to you because I feel like it's very important to not just show just the pure functionality, you know, snappy, fast of how we construct things, but also to ingrain into you that it's very, very important to have everything set up in a clean way so that if you need to go back to it in a month, you still understand what the hell is going on in your scene. Trust me, that saves time, a lot of time. So that's 1, dowels 15, that's correct, and 16 I guess, yep, that's correct. And the main one I'll rename to L2 main. There we go. Okay, so legs and the top are done. Now we can also do the dowels in the top. So if I were to remove the top from here, these guys, these guys right here. I want to be able to move them as well. So let's, actually I can show you this way. So I can take the top and I can take it off. Yeah, I can move it up. Then I can create a new scene and call it top dowels. And I can just select, holding down the shift key. No, I can't, never mind. I need to do it one by one. So I just select that dowel, put it in the top dowels scene, select that one, object 2, that's great. That one, object 10, that's great. And that one, object 8, perfect. Okay, so we have all of the top dowels done. Now what's left is, oh yeah, and also we need to not to forget to select the top scene and move it back to 0 height. So you control it here, 0. It's back to where it was. Now what's left is this slab right here. I will not put it in the scene, I'll just rename it into slab. Like that. And we have the feet. So we have, I'll just name it foot L1. This is going to be foot L2. I'm not putting them into groups. Foot right 2, R2, and foot R1. Okay, that's it. The preparation is done. We're ready to move on with the actual logic creation. Let's compile this and save this just in case for another crash so that we have it saved in the system. And let's first of all go to the construction script so that I can show you a little bit more easier the principles of how this whole thing works. So going back to the construction script, we have this single node that triggers before the game starts. And from this node, let's say I want to do something very simple as an example. I want to move the top. Yeah, I want to move the top up by a certain number, you know, by a certain amount. So first things first, I want to take the top scene and drag it into my construction script. So you just click and drag it in here. So now we can do stuff with it. From it, I'm going to drag out a wire and I'm going to write set relative transform. Actually, we just need to move it, so location is fine. Set relative location, right? This immediately gets connected as the target, as it should, and then we need to trigger this node to work for which we use the construction script, right? I just draw out the wire right here. There we go. And then for the new location, we need to understand that at the beginning, the location is 0, 0, 0 for all of these pieces, right? So anything that we add to the Z is going to move it up by that amount in centimeters. So what can we do? I can, one second, thinking. I can take, let's go for number. We can for now just as an example just write here like 20. Z 20 centimeters. Compile, save, look at the viewport. It's moved up, right? It's moved up by 20. It's not actually 20, I believe. This should be 40 given the offset that you have from the starting point, because they accumulate. So we will need to work with that. Every time when you use set relative location compared to set world location, you need to kind of shift your mindset of how it works. And I have a whole video about it. I will leave a link to it in the video description if you want to learn a little bit more on relative rotations, locations, and so on, where we do moving architecture. But in this course, you'll need to trust me on that. In this case, we use relative location and we use let's say static values. Static values is a good word to use in this case. I'm moving it back to 0. I'll look at the viewport and you can see that it didn't change. And the reason why it doesn't change is because it's not compiled yet. If I compile it, then it recalculates and it gets that information from here, and then it moves the top down to 0. Okay. So now what I want to do is I want to create this almost like a slider, a number that goes between 0 and 1 and is able to move the top in my viewport. So in my viewport, I want to be able to select the actor that I place, and in the options here, I want to have a number, and if I type in 0, the top is where it should be, and if I type in 1, the top should be moved up by a given amount, right? So we need to do that. To do so, we need to create a variable that will be called like explode percentage or something like that, right? That we will be able to change and thus influence the location. So to do so, I'm going to go here on the left-hand side, and under variables, I'm going to click the plus sign to create a new variable, right? And for the variable, I'm going to say, what did I say? Explode percentage or percent, doesn't matter, explode percent, right? Like that. Any variable in Unreal Engine can have a flavor to it, what type of variable it is. So by default, it's set to be Boolean, true or false, right? Boolean is either yes or no, right? That is the type of variable. No, our explode percentage needs to be a number between 0 and 1 with a lot of digits after the comma, possible kind of variations after the comma. So if I click on this Boolean, I expand this, you can see the most used variable types are here. And one of them is called float. If I just kind of quickly go through this, Boolean is true or false. Byte is, we don't use byte, we don't care. It's a 8-bit number, it's a very kind of lightweight number, we don't care. Integer, we do care about integers. Those are full numbers that don't have any digits after the comma. So 5, 8, 28, and so on. Then integer 64, it just is able to be a very, very big number, but we don't need it. Then we have float. Float is a number that can have digits after the comma, so it's more precise number. And then we have name, string. I will cover these a little bit later once we construct this further. So for now we're using float, right? Because 0.5 is a float number. It has 0.5 part to it. There we go. Select float. And I'm going to now drag this variable into my construction script right here. When I drag it in, it asks me, would we like to read this variable? Would we like to get the information from this variable? Let's say we typed in for the variable that it should be 0.5. So should we get that 0.5 number, or should we set it to something else? In this case, I want to get the number, right? So get the explode percent. There we go. And then for the explode percent, we want to somehow convert it to the movement in Z, right? So I can say, well, for this, This is a vector. You can see X, Y, Z. Anything that has 3 values is a vector. So I can drag out from here and I can say make vector. Wait, I'm thinking. Do we need to? Yeah, sure, why not? Make vector. Something like that. And we choose this option right here for make vector. And then if I just directly use explode percent into the Z, that does not really translate that well, because this is going to be, we're going to use this as if it's a value between 0 and 1, meaning that it translates to Z. If I connect it like that, it translates to Z to be between 0 and 1 centimeter. That's not a lot of movement, right? So instead, I will take this value and I'll actually multiply by 5, and then connect it to Z. This should give us a much wider range. Let's compile, save, go to the viewport, and nothing happens, clearly, because our explode percent, if I select this variable, you can see here it's set to be 0. What happens if I set it to 0.5? It opens up a little bit, you know, just a little bit, but it does. If I set it to 1, it opens up even more, even further, right? So now we're getting there with having some sort of a control, some sort of a slider that influences the height of the tabletop. The problem, actually, let's get this into our viewport. We want to see it here, right? So in the viewport, it's very simple. We go to our blueprint and we just drag and drop it in. Just like that, right? And the problem is that when I have this blueprint selected, remember that I said I want an option for that explode slider right here? I don't have it. I need to fix it. So I go back in here into my actual blueprint, and for the explode percent, there is this little eye right here that is closed right now, an eye socket that is closed. If I click on it and I make it open and I compile and save, this becomes available for anyone to change in, there it is. Make sure that it's selected, by the way, but it becomes available to change in the browser, viewport, in the viewport, right? So now I can increase it slowly, decrease it, and it moves, right? Great. So we have a way of how to control and how to check the movement that we're introducing. Also, why is scalability set to low? Epic. We're going for epic style here. Actually, I should save after changing epic. You probably don't see that option, so don't worry about it. All right. Still have a little bit of time. So with that done, I kind of want to, is it possible to, yes, it's possible. If I select explode percent here, you can see value range. I can define the smallest and highest values for both sliders and values. So I'm just going to hard code in that it should never go beyond 0 and 1, right? Slider range 0, 1, value range 0, 1. Make sure that the variable is selected. Compile, save. Now if I mess around with it, yeah, you can see I can't, it's impossible for me to drag it more than 1. Great. Back to the construction script. It's time to build it up. And I think before I do so, I will take a little bit of a break so that I don't skip over steps. So for you it's going to be instant. Okay, let's move on. So now we have a top that is raising up by not a lot, by 5 centimeters at the maximum. So I'll increase it to 10 centimeters so that it's a little bit more of a lift. And now we need to think about what is it that, let's look at the viewport, what is it that we want to do in terms of the animation for this. And I'm thinking of raising all of these elements, except for the feet, a little bit up from the, from the feet, right? So that basically the feet stay where they are and everything else is lifted a little bit up at first. So in the construction script, it's not just going to be the top that is lifted up, but also it's going to be everything else as well, right? So let's think. We lift the top dowels and we'll sort it out later. I know that this is not optimal, but it's a good way of thinking about it. So top dowels, I drag that in. Legs 1, drag that in. Legs 2, drag that in. And I just connect everything into the target. What else is there? Slab. Slab also needs to be dragged in. So everything except the feet. Compile. In the viewport, I select this. I increase this to 1. And this is how it looks like, right? So it gets exploded upwards just like that. Okay, let's say the feet are fine and the gap to the feet is fine. Now we need to, well, actually, maybe that's a little bit too much, isn't it? Let's do 5 instead of 10. I think 5 was actually okay. Compile again. Yeah, that's okay. Then we need to raise the top away from the legs and the slab, right? So I only want to raise the top of this. So what we do is we grab the top scene again, like that, and after construction script triggers this set relative location, we will trigger another node, which is going to be called not set but add relative location. Add relative location. The reason why it's called add rather than set in this case is because the top already has some location set, right, in terms of the Z height right here, and we want to add even more to the Z height. That's how we're going to be doing it. So we're going to use top for that as our target. And for delta location, I think we can just use, I kind of want to use like a vector that is 2 times longer. So vector in Z that is 10 rather than 5. So what I'm going to do is I'm just going to drag out from here, from this vector output, and I'm going to multiply this vector by 2. And here you can see it's a little bit annoying with the math, or not the math, but the input, but you can easily right click on this pin and choose, I hope that you can still see it, to float single precision, like that. And then I can just say 2 right here, just write 2, and use that as my delta location, right? That should do the trick. I compile this, and now if I look at the furniture, at the level, you can see that everything is raised by 5 centimeters, and then the top, the tabletop is raised by 10 centimeters even more, right? So even more location transform is added to the tabletop. Okay, now we move on. Now we do, I want to extract these, let me zoom in. 1 second, near clip, set near clip plane, remember that one? Yeah, 0.1, there we go. So I want to get these dowels also extracted and moved up. That's why I have top dowels right here grouped up into one scene. So I drag it out, top dowels, and I will be adding add relative location to those top dowels, like that, bam. And by how much? Actually, the delta location for the dowels, that's just going to be 5 centimeters because the tabletop is raised 10 centimeters, so the dowel should be raised 5 centimeters. So we're going to be using the original vector. I could make another vector, but it's just nice to reuse the same node. So I'm just going to drag out from here, from the make vector, right into delta location of the top dowels. In terms of wires and the wire kind of cleanliness, you can see that now this long ass wire is crossing over multiple nodes, which is hard to read. So I will just double click on the wire anywhere, which creates this kind of a point. And if I hover my mouse next to it, you can see that there is this kind of move icon. And if I click it and drag, I can position the wire in a little bit of a cleaner way. This does nothing except for cleaning up the script. Okay, so that's done. We have ourselves, let me move this a little bit to the side. Oop, didn't catch that. And select that, or rather just move that one away. So we have, we should have, yep, the dowels are now floating in space. That is perfect. That is exactly what we want to see. Now I want to do, what do we do? I want to separate out the, 1 second, let me think for a second. I want to move this top portion right here to the left, this top portion right here to the right, this leg portion right here to the left, and this leg portion right here to the right. I want to do that. So we will have more add or set relative locations for them, right? So going back to scalability low again. No, epic. We go for epic. So going back in here into our blueprint, I could keep on creating the chain here over and over and over again, like a very large chain, but I feel like it's very annoying to then scroll through, you know, a long line. So instead we're going to use a nice node that is called sequence of events, right? So construction script connects to the sequence, and then the sequence first fires out from the 0 output. So we connect that to our set relative location, the first one, right? And the way it works, it sends out a signal through here, triggers set relative location, add relative location again. It triggers these three. And then once this is finished calculating, then it goes back to the sequence and then it fires out from the second output right here, which enables us to have a little bit of a cleaner construction, so to say, of like vertical, more of a stacked vertical construction of our blueprint, which is just nice. Okay, with that being said, let's keep going. All right, so Right now, we will not be moving the groups anymore. The groups have been moved as much as we need them to be moved. Now we're going to be moving individual objects. So the first thing to move is going to be this object right here called top1, together with its coloring mesh. Like, remember the red color, the nice red color in between? Let's show you that. So these two need to be moved like that, and these two need to be moved like that. That's what we're aiming for, right? So I need to know that, okay, this object 5 and top1 belong to the same side. I go into the construction script right here, and for object 5 and top1, holding down the shift key, select both of them, drag them in. I will, somewhere close to then 1 of the sequence, I will create set relative location. Setting relative location per object basis rather than the group. And don't forget to connect both of them into the target. Okay, so we drag out the trigger from the sequence like that. And then in terms of the location itself, well, we need to do some thinking. First of all, it needs a vector, right? So we will make one. Make vector. That's easy. We will make a vector. Then it needs some sort of a... Sorry, I'm thinking. It needs a y value. Yeah, it needs a... It's going to be moved in y direction. Here on the left-hand side, I can see the green icon in the bottom left corner. And I can see that this part needs to be moved in a positive y direction. Okay, that's what we're going to be doing. Positive y. By how much? Well, we need to use the same explode percent first of all. So I drag out the variable again, get explode percent, and we will multiply it again, multiplication. We'll multiply it by how much? Do we do 10 again? I think we do 10 again. 10 centimeters. And I just connect it to y. I think that's gonna be enough. Let's compile it and let's take a look. Yep. Perfect. Just does what we needed to do. That's excellent. Now, for the other side, we kind of do the same thing, right? So I am going to first grab both of the other side's top elements. So it's going to be object 6 and top 2. In construction script, I'll drag them in. Set relative location for them, connect them as our targets. And then for the new location, we actually don't even need to make a vector. We can reuse this one, except that it needs to be other way around, right? It needs to move opposite from where this one is moving. Hope that makes sense, right? This part moves to the left, this needs to move to the right, so in negative y. How do you do that? Well, you take this and you just multiply it. Multiply this vector by -1. This is, again, we need to change the flavor of this by right-clicking to float or integer, doesn't matter. I'll use to float -1 and connect that to the new location here. Compile, look at it in the viewport, perfect. By the way, if you want to see it in the viewport in the blueprint here as well, all you need to do is just set the explode percent, the default value, to 1 right here. Then you'll see it exploded, right? That's how it works. A little bit crashy. Anyway, So I'll compile this again. Where we're good to go, we continue on. Back to the construction script. So now we have these two done. I need the legs to move out in negative x direction and positive x direction. So we go on, we move on with that. So in terms of the legs, give me a second, I'm thinking. In terms of the legs, we just, let's just take one, L1 main. I know that that is going to be the ones on the left, so they will need to move in negative x on the negative x vector. Okay, so L1 main, we get it here. As per usual, add or set relative location, like that. And then we make a vector. Do we kind of use the same value from explode percent? I think we should use a different value. So let's get explode percent. We multiply it by not 10, but let's do a little bit more. Let's do 20 and connect that to x, right? Compile, check the viewport, and it's bad because it goes in the positive x, right? We need it to go in the negative. So I go back to the construction script, and here this vector will need to be multiplied by -1 to float. -1. I know I'm speeding up, but I mean, it's a repetition, so hopefully that it's not that big of a problem that I'm going a little bit faster now. Compile, save. Now this looks fine. Time for leg 2, L2 main. Where is it? There it is, L2 main. Set relative location. Bam. And for this one, we don't need to multiply by -1, so we just use the original vector from here, right? Because it goes in the positive x direction. Check that one out. Now this is moved. This has been moved out. Last bit, in terms of static movement, that's going to be the pins right here, or the dowels right here. So we will need two more of these relative location and rotation values. So let's first get the dowels. So from leg 1, this one and this one, those two are the dowel joints. Set relative location, like that, like that. And they need to move, so we're talking about this side, so they need to move in negative x, but they shouldn't move by exactly this vector. I think this vector that is used to move the legs is too big, right? They should move like halfway there, always. So we just take this -1 multiplication and we divide it by 2, like half of the length of the vector. So divide, as per usual, change to float or integer, really doesn't matter. Divide by 2, like that, and use that as our vector right here for these dowels. We're almost there, I promise. Viewport, you can see the dowels are now sticking out, right? On this side, we need to do exactly the same thing. Ooh, come on, like that. Set relative location for the dowels, like that. And in this case, the vector should not be negative, it should be positive. So we will be still using divide node. So I'm just going to copy it, Control C, Control V. I'll connect that to the new location of our final two dowels on the right hand side. But since they need to use the positive value of the x, we don't feed the multiplication of -1, but rather we just simply feed the original vector like that. Bam. That's fine. Doesn't look that nice, but for now that's fine. That's it. Compile, save, look at it. Looks nice. Select it, change the explode percent to 0. Now it's constructed. Now it's exploded. 0.5, it's half exploded. Works like a charm. Okay. With that done, there is a little bit of a problem, and the problem is called, well, there's no way for us to, when we press play, there's nothing for us to press here, or any button here, to make that bench exploded. That's one thing. Second thing is the textures are wrong, right? This is nice, this is not nice. So first let's fix the textures, and then we will fix the, we'll map some sort of a button that we have on the keyboard to exploding and reconstructing this. All right, so first of all, let's do texturing. Back in here, in our blueprint, under viewport, we can now easily select the objects and, for instance, this one, and apply a material to them right here. Which material, you might ask? Well, we can always check. Oak veneer 2, oak veneer 1. Okay. So this is going to be oak veneer 2. I can just find the material here under instance. That's going to be 2 actually. That's going to be 1. That's going to be red. And that's going to be red. You can do this for multiple elements as well. If you just select, for instance, all of the dowels here, the floating dowels here on the left hand side, you can overwrite all of their materials all at once by just fishing out where the hell the dowels are. Megascan, surfaces, chipboard, and just using that like that, dragging it in. Same thing for the dowels right here. So 1, 2, 3, 4, chipboard, drag it in like that. The feet, same thing, foot, 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 foot. I think it's under instance, light gray color or white glossy. Let's go for white glossy for the feet. A few last bits. The slab, I don't remember what the slab used. I'll check with the original. Oak veneer 3 was used both for the slab as well as the legs. Okay, so slab, L1 main, L2 main uses oak veneer 3. Bam. That's it. Compile, save. Now these two objects are virtually identical, except that this one, if I now type in 1 here, it explodes. Congratulations, you have made it. Time to delete this one. We don't need it anymore. So I'm going to just find all of the bits of it on the right hand side here in the outliner, and I'll just hit delete to get rid of it. Then I'll select this object right here, and I'll make its location 0, 0, 0. Actually, I'm going to give it like 1 millimeter of an offset, maybe less, 0.05 millimeters of an offset, so that there is a little bit of a contact shadow right underneath it. It's just nicer that way. If we press play, yeah, same thing as what we had before. Nice. Right, now on to mapping our keyboard to the transformation of the object. That is important. So T1, T2. Up until now, we were working in this construction script tab, right? But now we will be moving, delete those, we will be moving into the event graph, because that is what happens when the game begins, right? So a very easy thing, actually, very easy, thing to do is to just select everything except the construction script. Don't do that, but select everything else, just like that. And copy, Control C, go to the event graph, Control V. Copy and paste and then drag it, I don't know, somewhere here, somewhere nearby. So the functionality that we're going to be using for the movement is going to be identical between the two, right? Between what's happening after you play the game or during the game time and before the game time. The logic is exactly the same. So that in our event graph, we need to create an animation basically that would play when you press a button. And an animation is made by using what's called oh my god, I'm blanking out. Not sequencer, that's the sequence. Timeline. Add timeline. And let's call it like T1 timeline, underscore timeline. Something like that. Okay, so this thing right here, inside of it, can have multiple tracks that play out your animation, right? And basically those tracks just increase or decrease. In our case, will just increase or decrease a number. Guess what that number is? That's our explode percent. We will replace our explode percent with a number that is being increased by the timeline. It's gonna make sense very quickly, I promise. Let us specify that the track length that is going to be added will be 1 second long. The explosion or contraction needs to happen in 1 second. And let's click this plus sign for adding a track. Add float track means that the value that is going to be increased is going to be a single number, and that's what we want, right? So add float track, and I'm going to call it step 1. Step 1. I'll explain why it's called step 1 in just a second, but basically we're going to have two timelines, 2 tracks. And for step 1, let's create 2 key points on this timeline. So I'm going to right click, add key on this line, and right click here, add key. It doesn't matter where you click, as long as you're adding in 2 keys. Click on one of the keys, and here specify that the time should be 0, and the value that is being pushed out at that time should be also 0. For the second key, specify that the time should be 1 second, right at the end of the timeline, and the value should be 1. Then you can click these 2 icons here to zoom in properly into the timeline if you wish so. Okay, compile, and here click on the event graph again. So notice how you have, after you double clicked on the timeline, you have a second tab or fourth tab. That's necessary, right? That's the functionality of this one. Okay, so now when you play the timeline, and I will talk about playing the timeline in just a second, but when you play the timeline, in a second, a number that is pushed out from here, from step 1, is going to increase from 0 to 1, right? So what we do is, 1 second, yes, 1 second, thinking. Do we still use a sequence? We should use a sequence. What we do is when the timeline is being updated, when it's running, it should run the sequence. So all of these nodes should constantly check what the output is from here. And instead of explode percent here, we input step 1, like that. So I just literally deleted explode percent and replaced it with a wire from step 1. Right? Compile. Technically, I would say we're good to go, but we're not, because nothing triggers the playing of this timeline, right? There's no input here. Technically, you could say that event begin play triggers the play of the timeline, but I feel like in 1 second that would be just opening up once and too fast. Let's see. Event begin play, connect that to the play, compile, save, go to your level and press play here. Yeah, you can kind of see it raising up. So that's how it works, right? It raises up. Then, actually that was not that bad, right? We can play this again. Yeah. When the game starts, this thing triggers the timeline. It starts playing a 1 second, not animation, but like it's increasing the number, and all of these values, at least this part, get increased by an ever increasing number from here. Here, this is still using explode %, so we can, what we can do is we can delete this one and replace it with step 1 as well. Compile, press play, and you can see that something's funky. Let me press play again and notice the movement of the top. It moves at an angle, right? And the reason why it moves at an angle is because it both translates in the Z, the top plates are translating in the Z, and they're also moving away in the Y direction, right? So they're kind of going at an angle. We don't want that. We want them to first translate up and then slide outwards. This is why I call this step 1, or rather, let's go back to the timeline. That's why we are using this track that is called step 1. We're going to use 2 tracks, a little bit more advanced. So I'm going to click on this plus track sign here, add float track, and we're going to call it step 2. Step 2. Step 2 track is going to also have 2 keys, 1 and 2. And it's going to actually, 1 second, let me think. Yeah, it's going to, first it moves up and then it moves to the sides. So step 1 is moving up, step 2 is moving to the sides. So step 1, this furthest out key, the maximum, should already be finished before step 2 begins, right? Because moves up, that's the maximum, and then it starts playing to the sides, right? So this point should actually, click on it, click on this point right here. This point, its time should be 0.5. It should be finished by here, right? And then in your step 2, your first point in step 2, its time should be at 0.5. It should start from here. And then its end should be at 1, with value being 1 as well. Like that. Yeah. So this increases, and then this increases, right? So when we translate this into our event graph, by the way, now we have step 2. So instead, for this whole second part, we will not use step 1. Instead, we will disconnect it with Control key, by the way, to disconnect a wire. Control key, drag backwards. We will use step 2 and connect it there. Compile, save, furniture T1, T2, play. Perfect. Do you see the difference? Like that. Again, going up, going to the sides. Going up, going to the sides. That's important. Looks more natural, and also 0 collisions when it's being dismantled. Very important. Okay. Now, this is awkward. The event begin play is awkward. I want to be able to press a button, for now on the keyboard. Later we're going to do the menu, but for now on the keyboard, I want to be able to press a button. So with Control, I remove the wire. That will enable me to play this animation and also to reverse this animation. So I will say, I don't remember, key event, keyboard event, keyboard event. And here it doesn't really matter which button you choose. Let's choose S button, whatever, S button, because you can easily select this node. So this can be any letter you want. You select this node and you can edit what the input key is right here. So you can click on this keyboard icon, and then whatever button you press is going to be the trigger button. So I'm going to go for Z, button Z, and I'm going to Control C, Control V, because Z is going to be to play, and to reverse, play in reverse, I'm going to use X. So input key X for this one. There we go. So if I press Z, it's going to play. We connect it like that. If I press X, it's going to reverse. Compile, save, furniture, play. Z does nothing. X does nothing. Why is it that it does nothing? Well, I'm glad you asked. The reason is because this blueprint cannot read what you're writing, what you're giving it, right? It cannot read your keyboard. And it's just an optimization, because if every blueprint can read your keyboard, then it becomes quite heavy and it's unnecessary. So you need to specifically say that when the blueprint is in the level, when the game begins, it should be able to read what the player is inputting. So event begin play, we will use from this enable input node right here, where the target itself, the blueprint itself is enabling the input, or rather the blueprint itself will receive enabled input functionality, but the player controller, I believe it won't work as without us specifying the player controller. Let's see if just this works. Let's press play. Z, Q, no. Okay, so the player controller also needs to be defined, which is pretty simple. Drag out from here, get player controller, like that. Compile, save, play. Z, X, Z, X, Z, X, Z. Okay, we're done. We're happy. Okay, we have ourselves a working. Now this is done. Our blueprint for this bench is done. Now we need more functionalities from everywhere else to make this work even better. But well, good going for now. Good going. I think we are on the right track. Also, I really want this explode percent to be 0. It's weird to see it exploded from the get-go. Compile, save. Right, on to the next chapter. Let's go. Chapter 10, Camera Rail Systems. So we are going to do a little bit of a unique take on them, because if you go here to the quickly add to the project button, under cinematic, you can see there are camera rig rails available already for you, and I can easily place it here, anywhere, bam, like that, and I can take my camera from here and just drag it on top of the camera rig rail so that it's parented. And from now on, if I select this rig and change the current position, the camera moves. As you can see, what camera sees moves. An issue with this is that I cannot access this setting or this variable through for instance, user interface or anything like that. Only in special occasions can this be used. So what we're going to do is we're going to make a custom rig by ourselves, which is not going to be a big deal. It's just keep that in mind, that there is an available version of this, but it does not work that well within the Blueprint system. So we're gonna make our own. Okay, I'm gonna Control Z until the camera is unparented, and I'm going to delete my camera rig rail from here altogether. Now, I need to create a new blueprint that I'm going to call camera rail or cam rail. So in my blueprints folder here in the bottom, I'm going to right click, blueprint class, actor, and I'm going to call this actor or name this actor cam rail. Just like that, enter. I have my rail blueprint right here. Double click it to open it up, dock it as per usual, and start working with it. So a rail initially, essentially, is a line, right? Either a line or a curve, anything that you want it to be. A line in Unreal Engine is defined as a spline. S-P-L-I-N-E, spline. We can go here and add a component, and we can search for spline. Not spline mesh, just spline. Like that. And we leave its name the way it is, it's fine. And this is going to be the only component that we actually use in this blueprint, because that's the rail. We will anchor our camera on a point along this line. And this line, by the way, can have multiple points and you can move it around. I'll show you. I'll show you how to do that. For now, we keep it as simple as possible. Compile. We move on. We move on to the construction script. Okay. So in the construction script, what needs to happen is we need to take the camera in our scene, a specific camera in our scene, and we need to place it on the rail, right? And same thing will need to happen, of course, in the event graph, because we will be animating. It's the same procedure as what we did with the bench, with the furniture piece. First, we make it static in the construction script. We see that it works when we change the number, and then we make it dynamic in the event graph with the, not sequence, the other one, the timeline. So construction script. We will be grabbing a camera. How the hell do we get a camera in here? Well, you could create a camera from somewhere here. Yeah, there we go, Cine camera right there. But we don't want to do that because we already have a very nice camera here already set up and ready to go. So instead, what we're going to do is in the cam rail, the blueprint, we're going to add a variable, create a variable. So click the plus sign, and we're going to call it camera. Just like that. And that variable is going to be the type of that variable is going to be called cinema camera actor. So I expand this instead of blueprint, which is yes or no, we change this to cine camera actor. Object reference, not class reference, object reference. Right? So we're going to be referencing a single object in our level. And that is going to be filling in this variable right here. Of course, it needs to be, the eye needs to be opened for this to work. Remember the eye? This makes it so that we can access this. Let me compile, I'll show you. When the eye is open, that means if I take this cam rail and drag it into the scene anywhere, there's our line, by the way. And on the right hand side here, you can see this variable being shown, and then I can choose. I can choose to fill this variable with any camera that I have in the scene. So I can pick actor from scene like that. I can choose the camera, and now you can see that it's connected to my camera rail, just like that. I can also choose to take this camera 1 and just drag it onto camera rail, just like that. So that when I move this particular rail, the camera moves together with it. That might be useful. We'll see. For now, I'm not going to be doing that actually. For now, let's Control Z. Let's have them disconnected, right? Here. But if I select this blueprint, you can see that I have camera 1 picked as my camera to be used. Okay, back in the blueprint, now I know that this camera is the camera cam 1 in my scene, so I can drag it in, bam, and I can choose to get camera, just like that. Then we, what do? We should position it, right? 1 second, I'm thinking. We should position it on top of the spline, according to some sort of proportion along the way of the spline. So let's get the spline in there as well. Bam. And let's get spline length. Let's ask how long is the line, right? The curve. How long is it? We get a number. Then we can multiply that number. Well, actually, let's connect it there. Gonna be cleaner. We can multiply that number by a proportion. And for that, we're going to create another variable. Press the plus sign here. That is going to be called position, pos, spacebar on, spacebar rail. Position on the rail, right? And it's not going to be, of course, a camera, so we change this to a float value. Exactly the same thing as what we did here with explode % for the table desk bench thing. We use that exact procedure or variable for this position on rail. It's going to be like 0 start of the rail, 1 end of the rail, 0.5 right in the middle of the rail. Position on rail, compile. Don't forget the slider range. Change that from 0 until 1, from 0 until 1 here. Easy peasy. Get position on rail in here, drag and drop it in, get, and connect that to the multiplication. So we're getting the length and we're multiplying by, let's say, 0.5. That's half the length, right? We multiply it by 0, we get 0. We multiply it by 1, we get the full length. So then what I need to do is get the spline again and say get location at distance, I guess, distance along spline. Get location at distance along the spline. And distance should be just this, you know, the output of this. Again, full distance is when we multiply by 1, half of the distance multiplied by half, and then so on. Coordinate space, actually we're going to be using world coordinate space, not local. So it's going to be, we're going to get a position in the world rather than locally in the blueprint. So then for this camera, we need to set its world location. Set world location. That feels weird. Yeah, that's fine. It translates automatically. So it gets the camera and it gets the camera component. I kind of want a root component. Can I get a root component, get root component. Use that instead of camera component. Like that. Perfect. And then connect the location to the new location. And don't forget that construction script needs to trigger this for this to work. Like that. Bam. Compile. Now if I look at the viewport, immediately the camera does not care anymore what its position is. Actually, it just did. That's weird. Oh no, never mind. The moment I move this blueprint, the camera snaps to it again, right? So I can reset the camera position and I can mess around with it as much as I want. The moment this blueprint is recalculated, for instance, by moving it, it immediately snaps to the starting position. Then if I don't see the variable, camera rail blueprint, position on rail, the eye is not open. I need to open it up, compile. Now I see position on rail variable here. If I change the variable, the camera moves along the rail. That's all we need. That's it. We're done. There's the rail. A very simple method, but hey, that works. So now with this setup, we need to make, let's make at least 3 cameras, right? We kind of need to. So one from the front, one from the side, and one from the close-up camera. So I'm going to take camera 1 and I'm going to just copy it, Ctrl+C, Ctrl+V to camera 2 and to camera 3, just like that. And I will position camera 2, or sorry, camera 3 rather, right in the middle. And it's only camera 1 that is connected to the rail right now, so it's fine. The positioning will not change to something like that, maybe a little bit further out. Yep, something like that. Then for camera 2, I'm going to move it as close as I can to the surface right here. Actually, yeah, something like that, right? And then of course my 2 other cameras need to have their own targets. Right now I only have target 1, so I'll make copies of that as well. Target 2, Ctrl+C, Ctrl+V, target 3. So I have 1, 2, 3 targets. Target 2 is going to be used by this camera. And actually I'm going to now properly connect it, right? So that it is used by this camera. So look at tracking settings right here. Instead of target 1, we use scroll, target 2. And then also there should be focus. Where was it? Okay, fine. I will click on this little gear icon here and show only modified properties. So I can only see, there it is, which only the properties that I have been modifying. That just makes it easier to find it, to find the tracking focus actor to track setting. There we go. So now camera, oh damn it, this is camera 3. Camera 3 needs to track target 3. Makes no sense to track target 2. So we do that and actor to track target 3. There we go. And camera 2 needs to track target 2 here and focus on target 2. All right. We're almost there. We have 3 cameras, 3 targets. Now, what we can do is take a look through camera 3 and click this little pin icon right here, pin to preview, like that. Then select target of the camera. Just kind of position it a little bit lower, something like that. All right. so that the composition is a little bit nicer. Then actually, no, that's fine. And then for camera 2, we do exactly the same thing. We can unpin camera 3 now and pin camera 2, and its target 2 needs to be moved over to here. Actually, to maybe a little bit lower. Could we kind of want to focus on that area right there. I think that one is nice. And just move it down. The placement of the camera right now does not matter because it's going to be controlled through the rail. So instead, I'm just kind of positioning it arbitrarily. Then this camera rail, I'm just going to rename it to camera rail 1 so that I can Control C, Control V, Control C, Control V, camera rail 2. And then Control C, Control V, camera rail 3. Camera rail 2 will, oh actually let's turn off only show modified properties now. Camera rail 2 will drive camera 2. Camera rail 3 will drive camera 3. Just like that. So now if I move my camera rail 2 to somewhere here, and actually I'm gonna reset the X position of it to be proper, and I select the camera, I need to, wait, that's camera 2, I'm stupid. It shouldn't be there. Sorry, camera rail 2 is actually a close-up somewhere here. We will deal with that later. For now, let's focus on camera rail 3. So if I move my camera rail 3 to somewhere here, change its location in X to 0 so that it's directly centered, just like that. All right. Select the camera, pin the view, select the rail again. See how it moves when we change the position. And now we can actually start messing around with the rail itself. So notice how I can select either this point or this point, right? And I can just move them around. So I can, well, that's X. X is stupid. Let's just move it somewhere here, just like that. And now if I change position on rail, it's going to zoom in, zoom out, right? So for these rails, you can position the camera any way you want, or rather you can position the rails any way you want. If you want to create more, let's move it up, something like that. If you want to create more points or more difficult, how do you say? I'm gonna get it. More complex rail system, you can always add more points by clicking on the rail here and add spline point here. So you add a point and now you can make it curved, right? And also there's every point has these handles. I personally don't like curved rails because I feel like they are a little bit, I don't know, looks weird. So I personally delete, get rid of them and just use 2 points. Also for the points themselves, I prefer to not use curvilinear control points, but rather use linear control points. What I mean by that is if I go to camera rail, viewport, I select this, you can see that the control points that are here, I believe I can change them here. I hope I can. Right click, spline point type, instead of curve, we choose linear. Instead of point here, we choose linear. And now it's always going to be a straight line between the 2 points. It's never going to curve. I think the movement like that is nice. Right. Let's check. Let's position the cameras properly. So this one, select the rail. Whoop, you, whoop, you. Okay, that's good. Let's see how it looks exploded. That is a little bit too far. Yeah, I think that's better. Okay. So we have our camera 3. Then what about our, let's unpin this. Pin camera 1. What about our camera 1? Don't forget to select the rail when you want to move it, not move the camera itself. Exploded is a little bit on the boring side, so let's see. Perhaps, actually, first of all, how does it look not exploded? Like that, okay. First of all, it's looking too high up. So perhaps if we move this slightly like so. Actually, that's, oops, that is me messing it up. We need to move the rail itself. Apologies. Bam. Maybe here, something like that. And then this could go here. Let's see. Position on rail. Something like that. Could it go higher? Okay. And it should look at, let's see, target 1. Should look at somewhere here. Okay, let's move the whole thing out a bit and a little bit higher. And this target is a little bit lower. Explode the view here. It's not bad. I mean, it hides a little bit, but I think that's reasonable. I think that's fine. Let's see other angles. This one is not good, so I need to select that particular point and find like a nicer position for it. I think something like that. And then this could be even higher or lower. Let's do something like that. Yeah. Okay. And then when it's constructed, is it? Yeah, that's fine. That places itself quite well. Okay. So this is done as well. And last one, right here, we unpin this. We pin this camera. This one is actually very close to succeeding. Let's see. The rail. Yeah, that's way too much movement from a close-up. Still too much. Maybe. And then when this explodes, we only see that part. That kind of sucks, honestly. I mean, that's too much. Let's move this back like that. Get something in here. Something like that. And then this back to 0. Maybe a little bit lower. Or maybe the target can go a little bit lower. Where's the target? The target is here. Can we focus on this? I'm looking at the crop right here. There we go. Just completely wrong. Like that. Rail 2. Yeah. That should be fine. And this exploded now. at least gives you a little bit more information. All right, okay, we have ourselves 3 cameras that are placed correctly and that have the capability of animating. With that being said, right now, if I press play, nothing moves, nothing animates. I mean, I can still explode and construct, right, from previous part, but the camera doesn't move. And that's because the camera rail in the event graph has nothing to do, right? Nothing happens. So what do? Well, we do take the construction script, right, that we have, and we just copy everything into the event graph, just like that. And of course, the construction script start does not transfer. Then for this event begin play, blah, 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 we don't, no, we don't do those. We don't do those. What we do, what we do is we create a special event that we will be able to trigger from anywhere, from the level blueprint, from the user interface, by pressing a number, whatever you want. So we will create a custom event. So let me delete that. And let me here, under event dispatchers, right here, create my custom event. Press the plus sign and type in, I don't know, trigger animation. Trigger anim, like that. And I take this and I drag this in here and I choose event. Trigger animation event. There we go. So now when this event is triggered by anything else, we will use level blueprint to trigger it. When this event is triggered by anything else, what's going to happen? It's going to fire out from here, right? And it's going to play a timeline. Yes, we are creating a timeline again. I'm not going to name it even. And it's going to always play the animation from the start. So every time you trigger it, it's playing from the start. And then when it's, okay, let's create a timeline first. How big should the animation be? How long should that animation be? Well, I think it should be like 50 seconds, something like that. So that it's kind of very slowly moving back and forward. Let's create a track. It's going to be float again. And I'm going to call it a sinus wave. The reason why it's a sinus wave is because I want it to go up to the end, so from 0 until 1, and then from 1 until 0, back again. So it needs to be this nice curve. So what we do is we create 3 points, add key, add key, add key, create 3 points. First one is going to be at the time of 0, it should be 0, right? So at 0, value is 0. Then the last one is at 50 seconds, the value should also be 0. But the middle one at 25, the value should be 1. And let's focus in by pressing these 2 buttons, bam bam, and it creates this jagged line. I don't like the jaggedness of the line. I think like it's stopping and playing back is going to be not seamless. So I'm going to right click on these points and choose auto, like that, auto, like that, auto, like that. And now this curve is nice and smooth, right? So that's it from the timeline. Going back to the event graph, the sinus wave is going to, in the time of 50 seconds, is going to spit out a number that is going to be between 0 and 1 and then back to 0 again, right? So we need to use that as our position on the rail. Simple as that. We connect that like so. And then we use the update trigger to set the world location, just like that. That's all you need to do. Compile, save, and then if I press play, nothing happens again. Why? Well, because this trigger animation event is not called, is not triggered by anything, right? We just created an event that does not get triggered ever, because there's no button that I can press or anything like that. So I think the simplest thing to do is to actually go back to the level blueprint and make it so that when we start the level, the camera through which we are looking through, its rail should start moving, right? I think that makes sense at this stage. So what we're going to do is we're going to say, I'm thinking if this is too complex for you or not. No, it's going to be fine. Trust me. So we're going to open our level blueprint. And then before we look through camera 1, we want to also play the, how is it called? The trigger animation event for the rail of camera 1. So what we're going to do is we're going to get all actors of class. And there's a problem. When I get all actors of class and here I choose rail, camera rail, there is a little bit of a whoopsie. And the whoopsie is called, well, we have 3 of them. And all 3 of them are identical. So the level will have no idea which one do we actually need. So as a way of how to specify which camera actor is which, we will use a tag system. TAG, tag, a tag system. So for camera rail 1, I'll select camera rail 1 and I'll search for what's called a tag option, actor, advanced, tags, and I'll click this plus sign and I'll give it a tag right here. I can just write anything I want. Cam 1, right? The tag for it is going to be camera 1, cam 1. Then I'm going to get cam rail 2. I'll call it cam 2 or give it a tag cam 2, caps lock C. I don't think it matters, but still, cam 2. Camera rail 3, add tag cam 3. And now I can stop searching for the tag name, right here. So I'll click the plus sign. With that done, now it's easy for us to fish out which camera rail are we talking about. Going back to our level blueprint, instead of using get all actors of class, we will be using get all actors of class with tag. This tool right here. And the tag is going to be called, which camera are we looking through? We're looking through cam 1 when we start the game. So we will say tag for it is the tag that we wrote for rail 1, which is camera 1. Actors is going to be cam rail, right? Actor class is cam rail, and we just trigger it. And what it spits out a list. In this case, the list is only going to have one single rail that has that tag, but it still spits out a list of actors, you can see by the icon, that all have the tag cam1, and also that are derived from the blueprint camera rail that we just created. So we need to get a single item from this list. So for that, and we know that it's only one because we wrote the tags, right? So what we're going to do is we're just going to get a copy, and then we're just gonna get the first item on the list, index 0, and it just gives us the, you know, the correct rail. And then for this, now this is gonna be easy. We just trigger animation, trigger anim event, trigger animation event, right? We trigger this, we trigger this, right? Like that. Don't forget to constantly connect the trigger wires and connect that to set view as well. All right, so now what happens is we press play, it gets every single camera rail in the scene, and then it filters out only the ones that have tag that's specified camera 1. It gets the first item on the list, which doesn't matter because there's only one item on the list. So technically this does not even need to exist, but it converts a list into a single item, so we use it. So it gets the correct rail and it triggers the event, this trigger animation event for the timeline in that particular rail so that it starts playing. And then it looks through camera 1. Compile, save, press play, and now this is moving. All right, that's how you control it. So let's say you don't want to look through camera 1. Let's say you want to look through camera 3, right? Also, let's unpin it. So in our level blueprint, you can here change to camera 3 tag, and also instead of camera 1, let's make this blueprint smaller. Just drag out the name, right? We can drag in camera 3 in here, like that. Just connect it here. Compile, save, play. Now we're looking through camera 3. Neat, isn't it? And don't forget that you can always Z and X. All right, so that concludes our chapter 10. I don't even know. Let's move on to the next one. All right, so let's talk about UI. In terms of creating UI in Unreal Engine 5, it's actually it's not difficult, but it's a little bit annoying because everything needs to fit on different proportion screens and so on. So all of the elements of the user interface always need to follow with certain relation rules to other elements, right? So when you resize the screen, the UI user interface does not mess up too much. Before we do that, I want to show you one issue that we should solve, and that is if I now press play, this is fine, right? Everything is in order. But if I zoom in right here to the middle portion of the bench and I press play again, there's this sphere here, right? That appears. If I then zoom into the right hand side of the bench, right here, the sphere is on the right hand side. This is actually your actor, the player character that is traveling in the scene. It's regarded as a sphere in this particular template. We don't want it here. It's annoying to have it here. So what we need to do is we need to change a few settings in our project settings. So here, open up settings, project settings. There we go. Open up that. There we go. Then go to maps and modes. And here under default game mode, you can see that it's set to game mode base. By the way, if you don't see the selected game mode rollout, just expand it. Game mode base. And here's our default pawn class. And it's set to default pawn. That's the sphere. We want to change this, but we can't. We can't change it because all of the default game modes are locked in, right? The settings for them are locked in. We need a custom one. To make a custom one, I'm going to go to the Blueprints tab folder, and I'm going to right click and choose to create a blueprint class. And here in the blueprint class, I'm going to first create a game mode blueprint, game mode base. Yes, game mode base, like that. And I'm just going to call it my blueprint or my game mode, just like that. And then here, instead of using game mode base, I'm going to use my game mode, which unlocks all of these different settings. So the main one being default pawn class, we need to change this. And to change this, I need to create my own character that has no form, that is a ghost. It does not have a sphere. So I'm going to right click, blueprint class, and choose pawn. A pawn is an actor that can be possessed and receive input from a controller. Yeah, sure. We create a pawn, and I'll call this my pawn, like that. And default pawn class is going to be my pawn, just like that. And that's it. I think now if I press play, there's no sphere here. If I look at the middle of the bench, press play, there's no sphere here. We have solved it. No more issues there. Okay, now for the user interface. That's more fun. First of all, let's create one. So in the content browser, content folder in the content browser, we will create a new new folder that is called UI, user interface. Expand that. And inside of that folder, I'm going to create, let's just create the UI inside of that folder. So right click, blueprint class, I believe. It should be widget blueprint. So let's see, blueprint class. Is there a widget? All classes. That feels like we're user widget. That feels like we're going at it in the wrong way. So I'm going to stop that, and instead we just right click and create it from user interface. Of course, user interface. You don't see it? No, you do. You do. Right at the bottom, widget blueprint. Bam. A widget enables US accept blah, blah. We will be just using the common user widget for this. Bam. Give it a name. I'm gonna name it GUI. Double click it. And this is a two-dimensional screen that can be placed on the player's screen, right? So anything that is done here can be placed, I guess, or it can be pushed on the level. So the first step is always to create a canvas panel. And if I search here, or rather editor, input, I always suck with these, the panel, canvas panel, drag and drop it in. And here on the left hand side, you can see that now canvas panel has been placed. This canvas panel can be resized to any proportion that you want. And what we're going to do is we're going to find 1920 by 1080. I think that's a good proportion at this point. But basically you will use this to see how all of your text changes according to different sizes and different scales of the screens. Since 1920 by 1080 is the most popular one, we're going to use that. So we have ourselves a canvas panel. Now in the canvas panel, I want to create how many actually? maybe 2. For now, let's create one horizontal box. So here I'm going to, in the canvas panel, I'm going to find a horizontal box. Means that everything that is stacked inside of that box is going to be stacked horizontally along a horizontal axis. Because I want text here, text to be placed here, I want text to be placed in the bottom, I want a line to be placed here. So horizontal box, there we go, it's under panel. Drag and drop it onto the canvas panel like so. There's our box. Of course, there are settings to be changed with our horizontal box. Main one being the anchoring. So this particular horizontal box should be always filling the full panel, because we will be placing smaller boxes inside of it and stacking. So in this case, everything needs to be filled. To do so, as long as you have horizontal box selected, you can go to the anchors here and choose this fill option right here, right? Which basically anchors the box to the 4 corners, and then you just need to deal with the offsets from the corners. So you can see that there's large offset on the right and the bottom. If I reduce those down to 0, now the box is filling in the whole space. And you can see if I'm increasing or decreasing the offsets, you can control where the box is. For now, for this one, we just wanted to fill the whole damn screen. All right, with that done, now it's time to actually start adding in the elements. First one is going to be a vertical box right on the left-hand side. It goes from left to right, right? So vertical box on the left-hand side, bam, like that, right here. That vertical box will, do we use it as, one second, I need to think. I think we should use it as a color box. That would make sense, right? So we will use it as a color box, meaning that is going to be, the size of this vertical box will be set to automatic, but the padding, how much of an offset it gets, will be changed. I want it to be a little bit off from the left-hand side. So the padding for the left, I'm gonna do like 20 pixels, like that. That should be good. And nothing else really matters as much in this. So we're just keeping it this way. Inside of this box, I want to make a line, a nice line going through it, right? So for this vertical box, I'm going to create, well, actually there's multiple things that you can color. I think we will use a border, because border is very easy to color. So here under common, we use border to draw a line. So that gets anchored into the vertical box right here. And it is there, it's very small, right? So we need to fix a few things with it. First one being, we fix the padding, right? The padding of it needs to be, 1 second, I'm thinking. If this is filled, should the padding then be changed or not? Okay, sorry. The first thing being, instead of automatic size, it needs to just fill the vertical box completely, as much as it can, right? So it just fills it up like that. Then, in terms of padding, we want to have it offset from the top, right? So we don't want the line to start right at the top of the screen. We want to have a same gap as what we have here. So that's going to be 20, like that. And then from the bottom, we want it to be higher than 20, like 100 or so, like that. So we're offsetting it away. Okay. And then for the content itself, content color and opacity, I think white is fine. Do we change the alpha? No, we don't. We don't. We keep the alpha as it is, but instead we change the padding, because the padding right now is 4 and 2. That is too much. I think the whole padding on all sides should be 0.5 so that it results in 1 pixel, because 0.5 plus 0.5 is 1, right? This is a weird way of making it, but it works. It works. So padding 0.5. Is there anything else, honestly? I think the brush color, like this might be a little bit too intense. So for the brush, I'm going to use like a, well, actually let's just change the alpha. So for brush color, I'm going to use alpha of 0.66, 66%, like that. So it's just a single line. With that line drawn, actually, let's see it on the screen, right? I think that's gonna be more interesting. Let me compile and save this. We have our user interface, and I want to draw this line onto our screen right here. How do I do that? Well, you do that in the level blueprint. Open level blueprint, like that. And in the level blueprint, you will have, we already have this chain of the camera control, you know, where the camera is made and so on. Not made, but rather animated and looked through. And afterwards, we also want to draw on top of the screen. So what we're going to do is we're going to say, okay, when we press the play button, it should create UI, create widget. It should create widget with the class being, how was it called? GUI, I think I called it. Yes, GUI. That's the name of the widget that we use. GUI. So it creates it, but it does not show it. We need to show it. And that is going to be called add to player screen. And the target is, of course, the created widget, like that. If I compile, save this, and now press play, you'll see a beautiful 1 pixel wide line right on the edge. Congratulations, now you can write anything you want on the screen and it's gonna show. Right, let's move on. Let's create the menu. So coming back to the user interface right here, we finished with the line. Let's create another vertical box, but that box of course will be placed in the horizontal box, right? We're just kind of adding them vertically. So in that, sorry, give me a second, I'm searching for vertical, there we go, vertical box. I'm going to drag it on top of the horizontal box, just like that. This is our second one, right? This one, the second one, needs to have a little bit of an offset, I think. Because right now it's resting right on top of this, this line. So I think from the left-hand side, it should have an offset of 5 pixels. From the top, it should have an offset, or actually, sorry, instead of auto. No, auto is fine. We don't deal with auto. So from the side, it's 5 pixels. From the top, I think I used 20. Yes, 20 pixels. From the bottom, it's gonna be 100. I think 100 pixels. And from the right hand side, it doesn't really matter. I'm just gonna use 20 just so that it's clean, visually clean. Everything else is fine here. Okay, we have our vertical box. Inside of that vertical box, we're gonna start adding the menu items, right? So that will require us to do some text. Let me drink. In terms of creating the text, it's pretty simple. Actually, do we need to... First is gonna come the name, right? We're gonna do the name. So for this vertical box, let's create a horizontal box. See what I mean by tedious and annoying? Let's drag a horizontal box on top of this vertical one. So it lives here inside of the vertical box. And this horizontal box should have automatic filling. Actually, we don't do anything with it. It's fine the way it is. Inside of it, there's going to be two text items. So I'm going to drag a text from here into the horizontal box. One is going to be a company name. And the second one, drag another one. I messed up. Abort mission. Drag on top of the horizontal box. There we go. And second one being the furniture piece name, right? So the company name is Very Good Architecture Company.com if you want to check out what we do. It's very nice. Very good architecture, or rather, no, it's not going to be Very Good Architecture Company. It should be the name of the series, right? So Very Good Furniture. Very Good Furniture for this text. And then for this text is going to be the name of the name of the furniture, right? So we will use dash space bar. I already forgot T1, T2. Bench type 1. Bench type 1. I'm bad with names. Clearly. Right? So we have ourselves a little bit of a text right here. Then there's more stuff that I want to change here. In terms of the font, the default font is Roboto, which is actually pretty nice. I'm just going to make it light right here so that it's not too much. And I'm going to change its size to like 16 so that it's not too big, like that. I think that looks pretty neat, and I need a space bar after furniture. There we go. So now you can make this into variable and you can change it any way you want, but that's maybe for the intermediate course. Now, after this horizontal box is done, we need to give it a little bit of a breathing room, right? And then start listing camera 1, camera 2, camera 3, camera 4, and so on. So I'm going to create a size box. Size box right here. Drag it on top of the vertical box. Not horizontal, vertical box. So that it's right below the title. And the size box is honestly only going to have padding on the top. That's all it needs to do, is just have 150 pixels of padding between the text and whatever is going to come after the size box. That's all we need. That we're done with the size box. Then we need to create a button. We need to drag a button into our vertical box, right? So let's find where a button is. Right there. There's a button. Drag it onto the vertical box. It's gonna look ugly, don't worry about it. So for the button, what do we do with it? First of all, I want to rename it. So I'm going to rename it to button cam 1, because that's going to be button for camera 1. And then inside of that button, I want to add a text object. Drag and drop in like that. You can see it immediately slaps it in. And for the text object, I'm going to just change, I think, what's the size? 12, 14, something like that. So I'm going to change the size of the text to 14. It should be light, and it should be camera 1, like that. Camera uno. And in terms of alignment, I honestly think it should be... Something's off. One sec. Give me a second. I need to check. Well, we'll be able to... I'm looking at my notes. We'll be able to change the alignment any way we want later down the line, but I just don't want it to be centered. I want it to be aligned to the left, which is maybe fine. All we need to do is just select the text here and click on this horizontal alignment, and it's just going to snap in place as it should. With that being said, it's weird that it's not snapping in place immediately. Anyway, so for the text, horizontal alignment should be to the left, and the padding should be all zeroed out, right? So that there are no kind of weird offsets or anything like that. Then we don't want this button to have any color, right? So when it comes down to appearance, the background color should be fully transparent. So alpha we reduce to 0, like that. I'm thinking if there's anything else. The padding, there should be like additional padding of the button, because I can see there's a gap here that I don't want to have, and a gap in the top. So I'm going to quickly go through the button settings. Style, is it under style? There it is, normal padding, pressed padding. So all of this needs to be zeroed out. 0, 0. Okay, now this looks much better, right? Right? So now with this done, with the button ready to go, we can just copy it 2 more times. Control C, right here, Control C, come on, Control C, Control V, and Control V again. And then we just need to, with F2, rename it to like proper button cam 2, button cam 3, expand this, change the camera 1 to camera 2 text, change camera 3 to camera 3 text. There we go. We're Gucci. We're good to go. So in terms of camera buttons, it's ready to go. We're done. Now we need to change the what's the word? The explosion button, or we need to make one. So I'm going to make another size box, which is our spacer, right? We use size boxes as spacers in this case. It's gonna be under the vertical box, size box. And this time I'm going to say from the top, give me like 50 pixels. Then give me a button, Control C, Control V. And I need to drag this button underneath the size box. And notice that there are many ways, like when you're dragging things, there are so many ways of how you can, where you can dock. So this icon with the little arrow sticking upwards is what you want. You drag it like that. And now the size box is between your camera 3 here and, well, this button right here that we will rename right now. So I'm gonna call this button exploded, and the text for it is going to be explode construct explode / construct with 2 space bars between the near the slash. Okay, almost there. Now the final thing is going to be, we also want to be able to change the color, the materials of our bench, right? So there's going to be one more size box right here, sorry, under the vertical box, like that. That spacers, maybe we do 50 again, right? Like that. I didn't write it for some reason. 50, there we go. Then we do another button, drag it down, rename it to button mat 1, material 1. And just change the text of it to style 1. Did I mess up? I messed up. I need to copy paste button mat 1, change it to mat 2, and its name should be style 2. Whew, okay. So close. So close. All right. So now on to the in the bottom. I want to be able to change the, or actually no, since we have a nice line here, I want another one right here on the opposite side. So we're actually going to create another vertical box in this this large horizontal box. We have one here and one here. We're going to make one more here, right? So vertical box, drag it on top of the horizontal box, like so. It's placed right here. And we're going to, for this, we're going to use fill. So it fills like that. We're going to give it padding of 20 from the right this time, not the left, so that the offsets are correct from both sides. We're going to say that its alignment should be horizontal to the left, to the right, and vertically it should fill the whole space like that. Perfect. And inside of it, we're making a border to draw the line. You already know this. We already did this. So border, drag it into the vertical box. Missed it. Drag it. Yep, there we go. There's the border. For it, we choose to fill. It's way too fat. So we go into the padding and we change the top padding to 20. Right, that's the offset that we're using. The bottom is 100. That is, again, the offset that we are using. Then we change the brush color, if I remember correctly. We used 66 for the alpha, 0.66, 0.66. For the alpha, what else? Padding, that should be 0.5, right? I think we use 0.5 for the padding, and then that's it. That's it. We have ourselves a line. Nice. All right. Vertically, we're done. Horizontally, we still need one last, or rather two last bits. One is going to be a horizontal box with two buttons, Scene Studio and Scene Interior, and below it we're going to have another nice horizontal line. That's at least the idea. So where should this horizontal box be placed? I think it should be placed right on the canvas panel. I think this one, right, the one that we have now, does its job, and we are not going to mess with it anymore. But this one below should, yeah, it should be right here at the bottom. That's gonna look nice. So I'm going to make another horizontal box, drag it on the canvas, like so. I'm going to say that it should be anchored to, let's see, now we're anchoring it right through the middle, right? Like that. I think so. Let's see. No, it should be anchored at the bottom. Sorry that I'm lagging here. I'm just thinking. If I do 0, 1 and then 1, 1, then it anchors to the two bottom ones, which are coincidentally this one right here, right? So we're using this anchoring method. Oh shit. There we go. And then in terms of the maximum, we don't change that. For the offsets, we don't change those. Position needs to be zeroed out completely, right? And the offset also zeroed out. Perfect. This is what I want to see. And then in terms of the size and Y, that's 30. That's fine. Now the question is, how do we change the alignment? I think we changed the alignment. And here for the Y, we can just slowly move it up until we see a position that we like. Let's go for some clean value, 1.75. And this is where we want the box to be. All right, inside of this box, inside of this horizontal box, we will have a gap, a button, a gap, a button, a gap. I think, yeah, that should work. So we will use size box right here, bam, like that. Then I'm just going to borrow one of the buttons from here. Control C, Control V, and just drag and drop it onto the horizontal box, like so. Then another size box. Then Control C, Control V, another button. And then another size box. Okay, so let me explain. We will have a gap here that is controlled by just using the fill option, which always tries to fill the full space. Then the other side, the gap on the other side right here, is also going to always try to fill the full space. Positioning these two right in the middle, right? The middle size box is just going to be used for padding, right? So we're just going to say on the left give me like 25 pixels and on the right give me 25 pixels. It just kind of separates out the two texts that we have here. And then everything else is just left for the buttons. So one button is going to be let's think. One button is going to be just called button scene studio, and the other button is going to be called button scene interior. Okay, and then the text of these buttons is going to be do we center them? Kind of want to center them, but I don't know if I should. No, they should be rather centered. They should be anchored to the left. Sorry, this button should be anchored to the right, while this button should be anchored to the left. I think that's the game plan. And now we just change the names. Scene studio. Okay, that looks fine, I guess. Scene interior. Interior. That seems to be off center, or maybe it's not. Is it off center? It's hard. I'm getting tired. It's hard to tell. Do we care that if it's off center or not? Not so much, honestly. Not so much. This is to the left. This is to the right. The buttons are. The size of the buttons are automatic, and the button here could be to the left, and the button here could be to the right, and here to the left. Besides that, that's fine. I mean, they do what they need to do. They're kind of centered. Should be okay. Yeah, let's move on. Last bit, creating a line. I'm just going to, just gonna create a line right on the canvas. So canvas panel, select that and drag in the, where is it? Border, hello? Am I losing my, okay. I'm gonna search border. There we go. Drag it on top of the canvas panel, like that. Border lives right here, and we just mess around with its anchors. So the anchoring, of course, should be the bottom portion, right? So we use that. So it's anchored. What the hell is going on? There we go. It's anchored right here. The position of it should be zeroed out. For now, I'm going to zero out everything like that. The size of it, I can just change the size. So I'm just going to see the size of it should be 1. So we're using 1 pixel for the thickness. And now let's just get the offset correct. Right, so the offsets on both ends, let's use like 300 by 300 for the left and the right. And the height, let's use, I wonder if it's going down or up. Yeah, it's going down, so it needs to be negative, I guess, 25, something like that. Does that seem good? That seems okay. All right. What else? Oh yeah, and also the color, the brush color needs to be 0.66, right? Don't forget the 0.66. Wait, did it save? Yes. Okay. Compile, save, play. There we go. Everything works. Nice. So we have ourselves a user interface that does nothing, but at least, you know, everything is in the correct places. Now if I change the canvas panel size to something like this, I can see how this whole thing reshuffles, and everything seems to be still, you know, centered and nice places. And if I change this to something very small, still we are getting pretty decent results. So that's great. That's what we want to see. We can move on with the actual functionality of our user interface. So how do you make buttons work? Well, here we are in the designer tab, and we have been in the designer tab for this user interface. There's also here on the top, you can see the graph tab. Yes. If you click on the graph tab, you can see, you know, the good old blueprint. The blueprint system is everywhere in Unreal Engine. So in this blueprint, you can call for what happens when specific buttons are clicked. So for instance, let's delete this. If I need these events, I will create the nodes again, so you can just easily delete them. That's not a problem. For example, if I want my if I want my button for camera 1, by the way, these buttons are right here. under variables. If I want my button for camera 1 to do something, I can just select it here and I can choose what kind of event I want to happen. So on clicked, if I press plus sign here, bam, it gives me the event of button camera 1 on clicked. So what should it do? Well, it should switch to the camera, right? So what I'm going to create is I'm going to create sorry, I need to think 1 second. No, all we need to do is going to be pretty simple. I'm going to get all actors of class with tag. Remember that? We already used this. And I'm going to say, give me all actors that have camera rail, that are camera rail, and that have tag cam1. Those are the tags that we wrote, cam1. All right, so it gives me all of them, and from them, it's actually only one, but from them I get a copy. I get the copy. Okay. Then I need to trigger that the animation plays for that camera. Trigger animation event, like that, and connect it. Okay, so when we press the button camera 1, it's going to at least start playing the animation for that camera. The camera is gonna start moving, but then we can also let's think. We can also get all actors of class again with tag again, but this time I'm going to say give me all cinema camera actors, cinema or cine camera actor in the scene that also have the tag cam1, like that. For this to actually work, right, if we look back at our scene, there's 3 cinema camera actors, 1, 2, 3. Neither one of them has the tag camera 1, only the rails have the tag, which means we need to give them proper tags. If I select camera 1 and in the options of it, in the details of it, I search for tag, here there's tags and there's actor. So under actor, under tags, I can click on this plus sign right here. Keep in mind, not camera component, not scene component, actor, advanced tags. I press this plus sign and here I write cam1, camera 1. All right, then for camera 2, same thing, plus sign, cam2. For camera 3, plus sign, cam3. That's it, we're done. Now the cameras are properly tagged and can be used, or rather found very easily. Now back to our user interface blueprint. Now this will actually fish out that camera, but we do need to get a copy. You always need to do that if an output is an array, which it is here. You can see from the icon. Get a copy. And then you can use the same thing that we used in the level blueprint, which is set view target with blend. So we will use set view target with blend. If it doesn't show up, you untick context sensitive and then you will find it. Bam. The target is not self, it's actually the player controller. So get player controller, and it's not under player state. It's not this one. It's not this one. You scroll up and you find the one that is under game player, get player controller, like that. And then for the target, yeah, that's the new view target. That one's easy, right? So this functionality now should switch to camera 1. Compile, save, press play. The scene begins. We press camera 1, bam, we switch to camera 1. Nice. No way to switch to camera 2 or 3 though, so we need to work on that. Back in here, we have this, oh, not here, sorry. Back in here, this user interface blueprint, we have this functionality set up. We kind of want to just copy it 2 more times, right? For camera 2 and camera 3. So we're actually going to be doing that, but you can't copy this event. You need to create events for button of camera 2 and button of camera 3. So we're going to do those first. Button cam 2, on clicked, press the plus. Button cam 3, on clicked, press the plus sign. Select all of these nodes, Ctrl C, Ctrl V. Nice, Ctrl C, Ctrl V. Nice. Connect accordingly. You know, cam 2 triggers this chain of events, cam 3 triggers this chain of events, and then just make sure to change the tags also correctly. Cam 2 here. There are ways of how to make this cleaner, you know, like just making it into a function and so on, but I feel like we don't want this video to be any longer than it needs to be. Compile, save, test it out. This is what we get. Camera 1, camera 2, camera 3. Camera 2, camera 1, camera 3. Works. Okay, we move on. Back to GUI. Now we have this button exploded, right? When the explosion needs to happen. And then reconstruction. On clicked. Again, we use the event of on clicked. We somehow need to, let's get into that blueprint here. BP, T1, T2, double click, event graph. When the button in the user interface, when this button is pressed, right, it needs to trigger this. And when it's pressed again, it needs to trigger this. It's going to be a little bit more tricky, but we're gonna manage. So first of all, let's delete Z and X. We don't need them anymore in our bench blueprint, T1, T2 blueprint. And instead, we're going to, again, create an event dispatcher, right? So we're going to make a custom event that works for us. And that event dispatcher is actually going to have, should it have 2? 1 second, I'm thinking, 1 second. Yes, there should be 2 events. Yeah, let's do 2 events. One is trigger explosion, and the second one is trigger explosion reverse, reversed explosion, right? So under event dispatcher, we press the plus sign, and we call this trigger explode. And again, we create another one. We call it trigger reverse. There we go. The trigger explode, drag it in, event, choose event. Trigger reverse, drag it in, choose event. Explode event connects to play, reverse event connects to reverse, clearly. All right. So now we have these custom events that we can call out to by simply fishing out T1, T2 in our GUI blueprint, in our user interface blueprint. So when this is pressed, we should get, I believe we should still get all actors of class, right? Yeah, we should get all actors of class, and it's only one bench in the scene, so we don't need a tag for it, it's only one. So get all actors of class, like that. And we choose the correct class, T1, T2. That's our blueprint name. We still do need to get a copy, still need to do that. But then from it, we trigger explosion event, trigger explode event, like that. And that's it. That's it. We compile, we save, we press play, and now I click on this, deconstructs. The problem is that when I click on it again, it doesn't reconstruct, and that is because this only triggers the explode event and it does not trigger the reverse effect event when we press it again, right? So what we want to do is we want to use this node that is very useful. It's called flip-flop. Flip-flop. First time you press this button, it's going to fire out from A. Second time you press this button, it's going to fire out from B. Third time, A again. Fourth time, B again, right? So this can be used in a very, very nice way by first triggering the explode event and then Ctrl+C, Ctrl+V, delete that, trigger reverse event the second time you press it, and then explode again the third time you press it, and so on. So we can have this kind of functionality: compile, save, play, explode, construct, change the camera, explode, construct, change the camera to something more interesting, explode, construct. There we go. We're getting there. Okay. Now, it's I think it's time for us to go for a short break and then continue on with the user interface and making sure that we're able to change the materials of this bench. Currently we only have one set of materials, so for that we will need to create a second set of materials, which is not going to be a big deal. We're gonna manage, but for that I need to take like a 10 minute break, and then we continue. Okay, then it's time to change some materials or create material options. Style 1, style 2. These two buttons need to do something. With that being said, also I noticed that when we play this game or this app and I click inside of the screen, there's one little issue. My mouse is not shown anymore. We need to change that mode of gameplay into something that is able to show the mouse constantly. I'm getting tired with my explanations. The mouse needs to be shown at all times during the app, when the app is running. To make that functionality, or to have that functionality, all we need to do is go to the our level blueprint, open level blueprint. And here, after we add the widget to the player's screen, we also want to set input mode to UI only, meaning that it's going to be only mouse. Only mouse input is going to be registered. We will use the player controller by get player controller, and that's it. No need to focus on any widgets. Okay, and then also this makes sure that the mouse is registered, and then we need to also set first get player controller again from the game, and then set show mouse cursor. Like that. And tick mark. Don't forget to tick mark that it should be shown. And that's it. After I compile and save and press play, now it doesn't matter where I click, the mouse is not gone, and I can switch between the cameras quite easily, and it just works. Nice. All right, moving on. Styles. So first of all, we want to open up our blueprint for T1, T2, like that, and we want to be able to change between the styles manually, right? And for that we use construction script as per usual. To do the manual change, we will need to add one more pin to the sequence, add pin, so that it first kind of explodes everything and then it does the material change. And then we will use a very easy or simple method of sorry, give me a second. Simple methodology of switching between materials, which will require us to use a branch. And the branch will have a condition yes or no. If yes, it fires out from here. If no, it fires out from here. And for that branch, we will create a variable here, and we will call that variable type toggle or whatever, so change type. So I will right click on this condition and I'll choose to promote to variable. That's a faster way than just clicking on the plus sign here, right? Right click, promote to variable. Bam, creates a condition variable here that we can now rename here as we want. Type toggle. Type toggle. And I will just open the eye right here. Type toggle, eye opened, so that we can switch it anytime we want, right? With that done, now we have this true and false statements, and let me show you the basics of it, right? If this is set to true, then this will fire out, and I will choose to set material. Let's see, for top one, or rather it doesn't really matter. Let me just delete and just drag anything from here. Let's go for, actually, sure, let's go for top one. Where was it? Top one? Top one is our, let me show you, this item right here, right? So for top one, that's the target. We change the material to, what is it using right now? Give me a second. Top one is using oak veneer 2. Okay, so if this type toggle is true, then it's going to be using oak veneer 2. Nothing changes. But if this type is false, then let me copy paste, Control C, Control V, connect false to this. It should use, I don't know, like let's go for red. I have the, where is it? Red color. Oh my god, how is it called? Red color, yeah. It should use red color. There we go. You can also drag and drop in the colors into here. That works as well, or materials into here. Okay, I compile, I save, I press play. Oh yeah, it doesn't matter. I don't have it hooked up to the button yet, so we work with this in the viewport. I select this object, and here I have my type toggle tick marked, and if I untick it, then this changes the material to red. I tick it again, it's wood, right? Oak. So that's how you change materials. Guess what we are going to do now? We're going to go through every single thing that uses the same material, and we're going to construct set material logic to it. So top one, sure. Then we do top two, which I know uses a different type of a material here. I'm just going to delete the bottom chain for now. We're just going to copy over. Top two uses oak veneer 1. Can I drag it over here? No, I need to, let's do it this way, like that. Then we will have L1 main, L2 main, and slab. All three of them will be using oak veneer 3. So let's find them. L1 main, L2 main, and the slab. Bam. Get them in there. Connect, connect, connect. And they use veneer 3. There we go. Easy peasy, but a little bit annoying, I know. Lastly, we want to change, the dowels don't change, we don't mess with the dowels, but we will be messing with the foot. So foot R2, R1, L2, L1, all of the 4 feet here are going to have their materials set to, well, in this case, it's gonna be, I believe, glossy white, something like that. White glossy. Great. That's kind of it for the version 1 or option 1. Then I copy paste all of this, and then we figure out option 2. So option 2 needs to be dark, I think, right? So we have a bright wood here, so maybe dark wood or something like that. I'm actually going to go and download from the bridge because I'm getting tired and I don't want to create another material from scratch. So we're going to just download some material from the Quixel bridge, and that's going to give me an opportunity to also showcase it too. Let's go for veneer. Are there any nice ones? We can do varnished walnut, I guess. I have that one. That one might be nice. Let's look into old varnished madrone burl veneer. Sure. Medium quality as well. Yeah, it is what it is. So we download that. We see that it's very red and very glossy. We might need to fix that. I'll show you how to. But for what it is, I think it's going to be fine. I will actually select this material instance right here, and I'm going to Ctrl-C, copy it, go into my instances folder, and I'm going to create a new folder. I messed up. I'm sorry. I'm going back to my materials instances. That's the new folder that I've created. I'm going to rename it to version 2. Open that one up and Ctrl-V. Paste the material instance into here, so that we can have like multiple copies of it and it's all gonna be neat and dandy. Okay, so for this material instance, the first thing that I want to do is make 3 variations of it. So, or rather 3 types of it. Do we do it now or later? Well, give me a second, just a second. Dark wood, I'm going to rename it first. Dark wood 1 underscore, no need to underscore, dark wood 1. Double click. r.raytracing.skylight 0. There we go. I don't know, it's very annoying. At least this fix seems to be working. So it's very shiny, but it might be pretty cool. Okay, let's make this a little bit smaller, and let's actually apply Darkwood 1 onto our top 1 version 2. How do you say that? Of our T1, T2 desk furniture piece. Let's apply the Darkwood 1 to the top 1 element of it, like that. Compile, save. That sucked. Go back to viewport, and let's select this and untick type toggle. There we go. So now we can actually see the material. And the nice thing about it is that as long as I've double clicked this so I have its options, I can change its options and kind of just mess around with it until there's everything's nice and neat and dandy. So first things first, the tiling. The tiling seems to be kind of off. I think it's too small. I think it's too dense. So I'm going to change the tiling to like 0.2 on both ends, which brings it to a little bit closer. Let's see the scratches. The scratches will say the most, I think. Are the scratches big enough or small enough? Yeah, I think that those are realistic. Okay, the tiling is still visible, so I'm going to make it even smaller, 0.15, but I don't want to mess with it even, like make it even smaller than that. I think that's good. Next thing is it's very red, so I don't want the redness to show. So I'm going to go to my albedo colors, tick mark that, and for saturation I'm going to drop it to 0.1 to make it gray, something like that. You can also apply a tint, but I don't want to mess with that. In terms of the brightness of it, I think that is doing just fine, so we won't be changing that. And then for the roughness, I think it should be just a little bit rougher, because it's very glossy right now. So for minimum roughness, I'm going to say, actually, can you be like 0.2 or 0.1, 0.15, something like that, so that it's not as, it's not as glossy. Shall we mess around with the normal strength? Well, let's increase it to like 3 or to 2. Don't go overboard with this. If you go overboard with the strength of the glossiness, then the normal strength, then it starts making mistakes. Actually 1.5 and minimum roughness 0.1. Yeah, something like that. Then in albedo controls, the brightness, I'll drop it down to 0.9 or 0.5, 0.6. Yeah, something like that should work just fine. Okay, that's it. We have our Darkwood 1. Now let me make 2 copies of it, Darkwood 2, Darkwood 3, and apply them to top 2 and these guys as well. So Darkwood 2 connects to here, Darkwood 3 goes on to be replaced for L2 main slab and L1 main. Compile, let's take a look at them. Okay, first step, the mirroring, right? You can clearly see that the texture here, the butterfly effect of the texture. So Darkwood 2 needs to have like an offset to it on both ends so that it does not look mirrored. for Darkwood 3, I think we're kind of good to go, right? Yeah, that seems fine. Yeah, we're good. We are good. Okay, so now we have an object, a table. Oh yeah, I forgot the feet. The feet need to become red. It's gonna look nice. So instead of white glossy, the feet are going to actually get the red color that we already have, like that. Nice. All right, so with this done, after I press play, I can actually see it from different camera angles. Very scratched, very scratchy. That maybe is fine. I think that's fine. Looks more solid. I don't know. But the buttons still don't do anything, right? So we need to actually make the buttons do something. And that happens when we, for our, that's the level blueprint, we close that. For our table, for the material change of the table, we're going to actually take this, and in the event graph, we will need to copy it into the event graph, right? I'm just thinking, how do we do that? 1 second. Because you press it once, you press it twice. Do we also need to use like 2 triggers? Seems to be an overkill with the 2 triggers. Give me a second. I'm just really quickly thinking. Yeah, I think we should just make 2 triggers, right? So for T1, T2, first of all, I'm going to copy all of these nodes that we have here, that we have created here, Control C, and then in the event graph, I'm going to just Control V, paste them here, and we're going to use 2 custom triggers, material change 1, material change 2, right? So under event dispatchers, I'll press the plus sign and I'll say material 1 change, and then material 2, mat 2 change. There we go, 2 triggers. Event, drag out and select event, drag out and select event. Connect, connect, compile, save. This is ready to, change its materials anytime you trigger it. Now going back to our UI, we actually need to trigger the material change. So we will choose button material 1 and we'll click this on clicked button here. Button material 2, on clicked button here. Okay. With that done, we will choose thinking. Yeah, with this then we just get all actors of class. We need to get that T1, T2 actor, our furniture piece. Get a copy. We get a copy and we, how is it called? Trigger mat 1 change. Mat 1 change event. There we go. We do that. Bam. And then we I'm just going to copy this for button 2. Instead of mat 1 change, it's going to be mat 2 change event. Connect that like so. Compile, save, play. style 1, style 2, style 1, explode, style 2, style 1, construct, camera 2, style 1, style 2. Okay, this whole side of functionality is done and we can move on. Oh, so nice. All right, so the next step is to actually have the last two buttons, Scene Interior and Scene Studio, have those last two buttons work. So we move on to the next chapter. Okay, in this chapter we're going to cover creating a different level and using the user interface to jump between levels, right? That is how we're going to actually jump between Scene Studio and Scene Interior right here, right? Those are going to be two separate levels because having everything in one level just increases the loading times too much. So under my levels, actually I want this to be tick marked. So at my on my levels folder, in my levels folder, I have this furniture T1, T2 level already kind of done. I would call this done. And now it's time to move on to creating the interior space for this level, right? So, so I'm going to select this level, Control C, Control V, copy paste. And I'll rename this to interior. Furniture T1, T2, interior. Right? So now notice that I can easily double click on it, save selected, let it save, and I just open up this level instead of this, and I can switch between these two levels as I please, right? And to just prove a point, I guess, let me just delete the environment and now switch between levels. And now you can clearly see that there is a difference, right? So now we have two levels that are different. Let's start with that. Let's start with being able to switch between those two levels in our user interface, and then we will build out the interior space level. So to switch between levels, all you need to do is, first of all, in your user interface blueprint, right? So open up your user interface, get to its blueprint. You have these two buttons, button Scene Interior and button Scene Studio, right? So we will choose the onClicked function for the button Scene Interior and onClicked function for button Scene Studio. And I'll have Studio first. So Studio at the top and Interior in the bottom, like that. Okay, with these buttons, once we click the button, what we want to do is we want to understand which level are we at right now. So get level name. Name. I think it's, wait. Get current, sorry, I'm stupid. Get current level name. Get current level name. It spits out the name of this level, furniture T1, T2, right? Or if you're in furniture T1, T2 interior, it's gonna spit out that. Then I want to ask, okay, is this level name, since we press the Scene Studio button, does this level name match as wildcard? Does this level name match furniture T1, T2? Does it match this? Furniture T1, T2? And if it does, then we know for a fact that it's the same level in which we're at, right? So we're going to create a branch. Going to create a branch and use that as our condition. So I'm pressing buttons. So what happens is you press a button, it reads the current level name and it asks, does it match with the level name of the studio? And if it does, then this gets triggered. If it doesn't, if it's a different level, then this gets triggered. So for both of these options, let's think of what should be done. If you are in the studio level and you want to get into the studio level, right? So you're pressing the button, nothing should happen, right? So this should be empty. You know, it just fires into nothingness. But if you are not in the studio level, then you should open level by object reference. That's easier, by object reference. And the level should be T1, T2, furniture T1, T2, the studio level, right? Like that. Then for the other one, the interior level, let's do it again. Get current level name, get current level name. See if we're already in it, matches wildcard. See if we're already in it, so it's going to be furniture T1, T2 underscore interior. That is not an underscore. Let's try to write underscore again. There we go. Interior, branch. That's the condition. And if we are in the interior level, nothing happens. But if we are not, then it should open level by object reference, and it should be the T1, T2 interior level, right? Compile, save, press play. Now we have two buttons here. Studio, I click on it, nothing happens. I click on the scene interior, bam. We switch to the interior level where I just deleted the background so that we know that there's a difference. Back to studio, back to scene interior. I'm switching to scene interior constantly. Switching to studio constantly. Right? Here. Oh, actually, why is scene interior still triggering? It should not do anything when I press this. That's weird. Let's investigate. Open level. We get the level name. It's a scene interior and it just triggers there. So it should not do anything else, but for some reason it triggers the event. Whatever. It's fine. It's fine. No one's going to be constantly clicking on that button. We leave it be. Right. So with this functionality, we're done with setting up for level change in our blueprint, and we're ready to go to our next chapter. Alright, so now it's time to construct our interior scene. And while doing so, I will be showcasing Datasmith. So my interior scene that I have here and that you will get access to if you support the channel on Patreon. My interior scene is made in Rhino and is, you know, a portion of a bigger house in Rhino. And you can see that it contains a bunch of B-reps or poly surfaces and some meshes for the fabric and so on. Let me switch to shaded mode. You can easily use any software that you want, and you just use the FBX export method for the interior scene as well. In this case, I'm using Datasmith just to showcase that for architectural visualization. As long as most of the stuff is kind of static, Datasmith mostly works. Truth be told, I prefer using FBX methodology of exporting, but it is what it is. So to use the Datasmith plugin with your scene, All you need to do is just select, is that a curve? No, that's an open polar surface, never mind. So what you need to do is just select everything in your scene that you want to export. Beforehand, of course, you need to texture it and like apply proper UV unwrapping to it and so on. But once you're ready to export, you select the objects. You, assuming that you already have Datasmith plugin downloaded, you choose to export 3D view right here. If you don't have Datasmith plugin, let's see if I can quickly show you. For Rhino, that's Twinmotion. I think it's both the same thing, but oh, that's, yeah, using Datasmith toolbar. 1 second. I'm sorry, this is getting a little bit annoying. Datasmith for Rhino download. There we go. That's gonna be fine. No, that's not fine. Are we there? Yeah, there we go. Finally. So Autodesk 3ds Max exporter, like there's so many different exporters. Even Archicad has one. That's very nice. Does Revit have one? Yep, there it is. Nice. Anyway, Rhino exporter, you download the exporter and then you have your Datasmith plugin that you can use. So you select your objects, you export 3D view, and you get your Datasmith file right here. For this, I will create a new folder, Datasmith export, like that. Interior space, Datasmith, that's fine. Hit save, and it's going to do the magic really quickly. Actually, exports really fast. There is also a connections tab where you can connect to Unreal Engine directly. So any changes that you make here will immediately be shown in Unreal Engine. I hate that with a passion, and I will not be teaching you how to do this. Every half a year or every year, I will be testing out for stability issues with Datasmith plugin when using this remote connection, and the moment that it's stable enough for me to show it to the public, I will start using it immediately. I think it's useful, but it has messed up so many of my projects that I would not recommend the live link. Instead, just use the export, static export of 3D view. You get the Datasmith file, you get it into Unreal, case closed. Okay, with that being said, under my geometry, I'm going to just create another folder, and I'll call this interior Datasmith or whatever. Interior Datasmith should work. Interior Datasmith, and here I will just go make sure that you're in the correct 1 second, I'm thinking, in the correct level. Make sure that you're in the correct level. And also, forgot, the units, as per usual, as always, need to be in centimeters. Notice what I've done here. Millimeters, right? Not centimeters, but millimeters. I want to see if Datasmith actually even recognizes that, because FBX does. If Datasmith recognizes that I messed up the units. So going back into Unreal Engine, bam, Datasmith, here I can click on this import button, or actually no, sorry, we click here. Sorry again, we first change the level to our interior scene, and then we click on the quickly add Datasmith file import, right? With that being said, if you don't see Datasmith file import, then you do need to go to settings, plugins, search for Datasmith, and make sure that Datasmith CAD importer is tick marked right here, right? So then you restart and then you get that functionality. Okay, Datasmith file import. We search for where the hell was it exported. So it's gonna be under furniture, export, Datasmith export, and there's our Datasmith file, right? We hit open. It asks us where would we like to have it copied, and we have prepared a folder for it. We hit OK. Asks us what is it that we want to load in. I know for a fact that the materials and textures are bad, so I will not be importing those. Instead, I'm just curious, not curious. I just want the geometry. For the advanced settings, for advanced static mesh settings, these are all the settings that you get. How the light mass is computed. Sure, I guess seems good. Why not? Hit import. It does its thing, slowly imports. Eventually, like that, there's gonna be a lot of stuff that's gonna pop up here. Give it a second. Okay, it's being built out. As you can see, nothing. You can't really see anything. So let me change this to unlit, so that we can at least see this in an unshaded mode. But the building is actually, or interior is actually here. And now I'll switch to lit again, and you can kind of see it, right? And everything seems to be textured fine. Okay, so those rectangular lights don't work anymore, are not nice anymore, so we'll need to fix those, and there's gonna be a few changes to be that we will need to make. But basically, in terms of the, what's the word? Anatomy. The anatomy of a Datasmith scene is that you have the scene actor as the main core. So here, interior scene, this is the main actor, and if I move it, the whole damn scene moves. So I'll just make sure that that actor is set to 0, 0, 0, and then that actor contains all other actors that are inside of the, or all other objects that are inside of it, right? Easy as that. So that's what's happening in the viewport. What's happening in the content browser is that in our interior Datasmith folder, interior scene was created, another folder was created. Inside of that, we have the Datasmith scene itself that I can double click. No, I can't. That does not care. I can just re-import it, I guess. And it's going to do its magic. But more importantly, it has all of these geometries here that we can use, right? And that are being used and automatically placed, which is very nice. So all of these geometries that we see here are just static meshes, same as importing FBX files, and we can deal with them as static meshes. So when you're importing multiple elements, the first thing that you want to check is here under lit, you want to change this to nanite visualization triangles to see if the objects that were imported are nanite. If they were, they would be remeshed, just like you see with the bench here, but they are not being remeshed. So that's not good. So we want to fix that. So I'm going to select all of the static meshes that I have in my interior scene geometries folder. Just shift key by pressing first one and the last one. Right click on them, on any of them, once they are all selected, asset actions, edit selection in property matrix, like that. Then here I will search for nanite settings. I will enable nanite for all of them. This will take a while because it's a lot of them. So give it a second. Basically, while it's doing this, I can talk. When you're enabling nanite, you're saying that every piece of geometry that is important should be remeshed dynamically, so that it's more lightweight for the computer, right? So if you're not looking at an object, it's going to be reduced. Its mesh count or polygon count will be reduced dramatically. Also, if it's far away. But remember, we had a problem with the light. So here under fallback target, instead of automatic, we will use relative error. And we will say that we do not tolerate any errors. So once this is calculated, we'll say that the relative error should be 0. If it's not 0, then the light, especially ray traced light, that is being shown on the object is going to be calculated against the lowest possible resolution mesh that Nanite can render or generate. And that usually just makes a whole lot of nonsense, right? So fallback relative error, this one, not the percent triangles, relative error, this one, 0. Once that is done, the shading is going to be fine. And the scene itself will be much, much faster. Click the save button just in case. Why not? Close that. We're good to go. Everything is Nanite. Congratulations. Let me show you this in action. See, I'm zooming out. I'm still zooming out. The mesh is increasing or decreasing in its density. Very useful. Why the hell? Oh, this is a camera. Never mind. Cameras cannot be Nanite, clearly. Okay, so that's done. That's very easy. That's very easy to do. Time to get some textures in here, I guess. So in terms of textures, there's not no real tutorial there. You know, you just download textures from Bridge or from Quixel Bridge or from the internet, and you just texture the whole damn thing, right? The only thing that you kind of want to do is you want to make sure that the interior textures are dynamic, meaning some of the interior textures are dynamic, meaning that there's going to be areas that are going to be replaced by actors, and I'm going to do that, of course, in this video, but a little bit later down the line. For now, let's just check real quick if we haven't made any mistakes. Yeah, of course, the camera is in the freaking bed and so on, but that seems fine. And then we switch to Studio. Studio is lovely. That works really well. We switch back to interior. Yeah, that's nice. Okay. So now I think it's time for a time lapse of me just texturing this whole damn thing. So let's do a time lapse. It's gonna be a repetition of what I've already done. Okay, we can continue with this. So a few key points. First one being, if you're interested more in this ArcViz whole situation, I have 2 courses that are already on the channel. Just Google or search for ArcViz Unreal Engine 5 course and you'll find them. I'll leave a link to them in the video description as well. 2 things that I don't show in the architectural visualization courses that I did here were, first one being I'm using a skylight. Skylight right here to kind of color the sky, and I'm using exponential height fog with a specific in-scattering color to make the background bright white. And the only thing with the fog is that its color is not just white. No. It's white to a high degree. So if I were to search for fog here, and I show you, fog in scattering color, this one is set to RGB values are at 100 rather than 111, meaning that it's 100 times brighter than just the color white. Because of this, it can fight, or it can battle it out with the lights that we have here, right? Rectangular lights that are shining through the curtain material. Speaking of which, I have created the curtain material. I just downloaded the map from Polyhaven, I believe. All of these textures, and for that I had to create a new master material here that it doesn't use metallic, instead it uses specular, and it uses the opacity map for transparency. And for it to use opacity map properly, here under blending mode, when you don't have anything selected in this material, under blending mode we want it to use translucency gray transmittance, right? So that it has opacity information in it. So that was those were the curtains. I'm happy with how they look like. I think they are pretty. Then in terms of this rock thing situation, that is just a surface that we had that is displaced right now, and you can see the displacement happening here. Of course, the displacement, does not have any information vertically, which leaves us with these with that mess. But to displace an object, you select it, you go to, instead of selection mode, you go into modeling mode. You need to go to the mesh and actually remesh it. There we go, either here, or was it under model? No, it's under mesh. You remesh it to give it more polygons. You saw me give it 50,000 polygons, and you go to the form and choose displace right here. At that point, from this rock cliff that I have downloaded from Quixel Bridge, I have taken this ORD texture. ORD stands for opacity reflection displacement, or RDP rather. I think it's opacity. It seems like it's opacity. So red, green, blue channels are coded into opacity, reflection, or roughness and displacement. So for us, I had to take out the blue channel. The displacement tool here actually asks you which channel you want, which is great, but at the same time it didn't like me using virtual texture, so I had to make a copy of this here, and I had to right click and choose convert to regular texture, and then it was happy and it worked out. You saw it in the time skip thing that I've done, time lapse thing that I've done. So now we have, a little bit nicer material here. Let me go back to the selection mode. Now this is a little bit too green, I feel like, but actually no. Let's keep it the way it is. Let's press play and see what other things we need to fix. Of course, the camera position needs to be fixed. Actually camera 2 is fine. That looks okay to be. I like the sheen and so on. Yeah, that looks just fine to me. Camera 3 is horrible, bad. Camera 1 is behind the curtains. That needs to be fixed. So let's work on the camera positions. I will just fish out the rails. Camera 1 rail. Let's get it in here. And the positioning of the camera is exactly as what we've been doing so far. What we've been doing in the previous scene, right? We just select the camera, we pin the view, we get the rail, we select the points, and we position the points properly on our scene, something like that. And perhaps the camera here, it could be a little bit wider. It seems like it's a little bit too focused in this case. So current focal length for this camera, I'll change to, let's go for 30 millimeters. That's a little bit too much. Let's go for 36 millimeters, something like that. And then this one right there, scroll, scroll, scroll. Yeah, that seems to be absolutely fine. Okay, so camera 1 is ready to go. Camera 2, I was already happy with it, so I think we're chilling with camera 2. Let me just move the rail a little bit lower. And maybe a little bit further out. Something like that. I really need to pin the camera 2 view of this and unpin camera 3. I think this will be a pretty cool look. And then if this is 1, then that point, I need that point of the rail. Come on, give it to me. That point. There we go. That point, I want it to be kinda there. I think that's going to give a nicer outlook. A little bit too much, maybe. Yeah, I think that's gonna look nice. And last one is, oh my god, this camera right here. Okay, so let's look through it. Let's pin it in. Let's unpin that. Camera 3 does need to, we moved the rail, not the camera. So camera 3 does need to start from here, definitely deeper in. It looks through the glass, so it can kind of go into the wall. That's not a problem. Something like that. Move it around. Yeah, that seems like it's gonna do the trick. And then for the camera itself, I want it to go wider. So instead of 60, again 35 or 36. Yeah, something like that. That looks fine. That looks good. Explode it. Why is this not moving away? Oh, we'll need to investigate what's up with the leg. Was this always this way? Oh no. Oh no. Okay, let's investigate that. If I select this and we increase this to 1, that works here, so that means it's something in the event graph. So for T1, T2, yep, there we go. Explode percent here is used instead of the actual step 2. So I need to draw out the wire like that. It's an ugly long wire, which is bad, but it is what it is. So step 2 was only triggering the motion of top 1 and top 2 here, but it wasn't triggering the motion of these 4. Now if I compile this and save this and press play, let's construct it or explode it. There we go. Constructs perfectly. Yeah, that's what I want. All right, so we're good to go. Scene studio, scene interior, nice. The only problem is now, or rather last thing that we need to do is this requires the interior qualities to change together with it, right? So our style 1, style 2 needs to also drive the interior qualities. To do that, let's change that back to 0. To do that, the interior part of the interior needs to be rebuilt into what's a good word? should be rebuilt into one object or one goddamn entity. The word is one actor, right? And that actor should be able to change its materials according to what kind of material is set for this. With that being said, I'm not sure if that is necessary for this particular course, because you already know how to do it from the T1, T2, right? It's exactly the same procedure as what we've done here. We create a new actor, we give it 2 material change events, and we just give it 2 material sets for one and for the other, right? Variation. And then inside of our GUI here, we just say that it's not, where is it? It's not going to be just the material 1 that is going to change its color, but rather it's going to be both materials. Sorry, it's not just going to be T1, T2 that it's going to change its colors, but also that new actor that we have created. But the whole chain is just a copy of this, as well as the copy of this, right? So for that, I don't think we should do this, because that just makes a video longer by just repeating the same thing over and over and over again. Right. Which, coincidentally, makes it so that our scene, like the interior scene, is finished. It's completed. I do want to do a few things here. First thing being, where is it? I want a spotlight to shine on this area right here, so that it catches, the shadows are being caught nicely. So I'm going to create a new light, spotlight. I'm going to position it to 0, 0, 0, so that it's easier to fish it out. There we go. Bam. Move it in here. Something like that. Very hard to see with that billboard in the way. I guess that should be at 0. Get that in there. There we go. Okay. So something like that. Then the intensity of it needs to be much higher. So let's do like 300. And then let's start messing around with different kind of angles and so on to see how we can make it just generally nicer. So attenuation is how far it reaches. It should be like at least 4 meters, right? Inner cone angle, that's how where the sharp light hits, and outer cone angle, that's where the soft light, you know, the gradient between the sharp and the soft. Then in terms of the rotation of this, we want it to rotate towards our rocky wall situation here. And I believe that is kinda it. Does it look good? Looks fine. We need to dial in a few things, and also in the example I had more objects here, more rocks here that I just downloaded from Quixel Megascans. I guess I can show you how I would do that as well. So in my 1 second, there we go. So in my Quixel bridge, I already have downloaded under 3D assets. Should be like Icelandic, how do I call it? Rocky assembly. Formation, rock formation ground. I wear a rock. What kind of rock would I be? Rocky assembly. Clearly that's going to help. No, that does not. Well, crap. Icelandic. There we go. This one. Rocky ground. I want this. I think. Yeah. This one looks the best, I think. Well, this one also looks kind of good. Or this. Oh no. Oh no. Okay, let's get this one. Or actually, let's get this one in. This one looks quite nice. And I'm just going to download that. Medium quality. We don't really need it to be that intense in terms of quality. Or that heavy. Also, I can't afford to have a very heavy 3D model here due to recording. I still want to keep it at like 60 frames per second at least. So with that rock done, I will right click it, nanite, enable nanite, you know, the typical things that we need to change. Fallback target, relative error, error 0. Apply the changes. Ask yourself the question, why the hell is it black? Okay, at least in neutral it shades properly, so that's good. Like the quality here is really poor, but we're never going to be looking at it up close, so that's fine. Back in here, I'm going to add it in, rotate it 90 degrees, scale it down. Apologies. Scale it down here, move it in. And perhaps the scale should be a little bit larger, something like that, but a little bit more pushed in. So actually the Z scale should be half of everything else. W to move it in, reposition, get it up in there, and so on, right? So you just mess around with it until you find like a nice placement for it. Something like that should do the trick. Then I can make a copy of it, rotate it. Let's do something like that. Place it there, move it in a little bit further. Right, so your whole kind of assembly of these type of rocks is just taking the asset and just copying it around until you see some nice effect, right? This one, let's say I want it to be a little bit more further out, 0.25, then this area is sticking out, so I need to push it in. But then everything it gets pushed in, so I will maybe move it out altogether, like that. Yeah, that actually does not look that bad. I will now lie about this light and I'll move it a little bit closer, but rotate it a little bit more downwards, like that. And it should be like 200. 300 is too much, so that it hits that particular point. It's never going to show up here like in these views, but maybe you will be creating, you know, some different camera angle, and then it shows. Just wanted to point it out that you create interest through repetition of simplistic things, and they don't really need to be that high of a resolution to work. I completely forgot one thing. We need to make the colors match. What the hell? Of course we do. So this is to brown, this is to green. Just selecting this object and going into its material right here, I can apply tint color, and for that I will need to see the object, albedo tint. And what's opposite of green? Magenta. So we can apply just a slight tint of magenta, and you can already see that it's getting towards that kind of brownish color that we want, right? And then for this, for these colors, I can also zoom in here, look at the material, and here I will just drop down the albedo saturation to 0.8. Save that. Yeah, that seems to be much better. So now it's a little bit more brownish. Yeah, that's what I wanted to add. All right, so now it's time for final packaging. Yay, finally. With a bunch of settings, I'm just opening up a few folders, with a bunch of settings still left to be adjusted. We're not out of the woods yet, but now at least we can see the end of the, we can see the finish line coming in quite soon. There are a few things that I still want to teach you. First one being how do you add sound to the menu, right? So when you click on something, it makes a sound. It's actually pretty simple. Let me create a new folder and call it sound or audio folder. And here I'm just going to drag and drop in any audio file that has a WAV file, so audio wave file that I can find. So I'm just really quickly skimming through. I'm sorry for making you wait. I have a bunch of effect files here, and I'm just going to use multimedia with plank flicks. What the hell is that? Let's see that. Oh, that's MP3. Never mind. We need WAV file. So Apple mouse click, sure. Oh, that's an MP3 again. Yeah. Electronic drum. Can we use that? Yeah, sure. I mean this is a little bit of an annoying sound effect. Maybe there's a better one. I'm just going to get a bunch of those in. There's a lot of free ones that you can download from the internet. There's a lot of expensive ones that you can download from the internet. Jesus Christ. That's not bad. That's bad. Sure. Let's use the pur. This one. So we're going to be using this one. I'm just going to be, let me drop down the volume a little bit more. Yeah, should be fine. So we'll be using this one every time we press a button. So here in our UI system, we can just simply, once the button for cam1 is pressed, we make sound. No, play sound. Play sound. Is it 2D? I think it's 2D. Let me actually double check. Or play audio. No, it should be play sound, and then we select the asset and we just drag and drop in the asset. I'm sorry, I'm getting tired, I guess. So we just take this and we drag it in here. Let's see if that's going to work. Compile, save, press play. Camera 1. Okay, so then we just need to do this for every single one, right? So you just inject display sound into in between every single one of the button presses. Not that big of a deal, honestly. Afterwards, once we're done with the sounds, I will also show you the post-process volume that should be used in both levels, but we're only going to use it for the or actually maybe no, we should use it for both levels. That's going to be cleaner. The post-process volume overrides the exposure controls. It overrides a bunch of things, really. You can overwrite a bunch of things. In our case, we will use it to control the like special effects such as vignetting and then so on. So with this done, now I can press play, and now right, and I can switch between different scenes and so on. Everything works great. Let's increase the quality dramatically. So I'll go to my initial level, furniture T1, T2, save everything for this level, and wait for it to load in. And here I'm going to create a post-process volume. So quickly add to the project, volumes. Is it volumes? I guess it's effects, visual effects, post-process volume, right there. W key, move it up, or rather let's just zero out the location of it, move it up, and just decrease the scale so that it's a small little box. First thing that you do in this post-process volume is you make it unbound so that it affects the whole level rather than just the area inside of it. Unbound. Infinite extent unbound, you tick mark that. Second thing that you want to do, or not second thing, but now we can go through all of the settings in the post-process volume and see which ones are there that we actually would like to work with, right? So for example, bloom, I could make everything, sorry. No, we don't deal with bloom here. Everything has soft light, so nothing will have a bloom. But for instance, the local exposure, we can, the camera, there it is, the exposure of the camera, we can force exposure compensation, meaning we can force a brighter scene or a darker scene if we would so choose. I personally like the way the scene is right now, so I will not be changing that here. In terms of lens flares, I usually tend to decrease the intensity to like 0.3, just so that it's not so over the top, because Unreal Engine likes to make lens flares over the top. Instead of, in case of image effects, vignetting intensity, I do enjoy vignetting quite a bit. You can see the darkening on the edges, so I'll have it as 0.5 maybe, something like that. Sharpening, we don't do that here. Then in terms of color grading, there's so many things that you can change, but I mostly just play around with the white balance until I see, you know, temperature that kind of works. In this case, again, we're using neutral white color light in a white color environment, so the white balance is not really necessary to change. We will be changing it in the other level though. In terms of shadows and so on, we don't need to change that. Global illumination, you can choose to use lumen for global illumination. It's already being used, so you don't need to change it. But in terms of the quality here, you are able to change how well this whole thing is calculated. So scene detail, you can increase that to like 4 or 2. Depending on your hardware. Lighting quality, increase that to 2. Finer gather quality, also increase that to 2. So now lumen is calculating much more accurately, right? Also for, where is it? No, it's not here. Not here, sorry, give me a second. It's under reflection, there we go. Reflection, also method lumen, quality, as per usual, 2. Very hard to see any difference, but let's do 0.25, right, in terms of lumen reflections, right there, and 2. You can see that that kind of grain in the top is almost not visible, or maybe you don't even see it due to YouTube's compression. Trust me, this helps. If you want it better, just increase it to 4, but this costs a lot, so we keep it as 2. Reflection bounces, you want more than 1, so we'll do like 3 reflection bounces. You can see that immediately more light gets in here, in this area. Nothing else here. Translucency, motion blur, ray tracing translucency, priority. Nope. Nothing else to change here. So hopefully this explains what post-processing volume does. Let's create one for our interior scene as well. Here, visual effects, post-process, where is it? There it is. Bam. Unbound. I like to create it last because I tend to overdo post-processing if I create it first. So I tend to create these days the post-process volume last so that I don't mess with it too much. In this case, for these views that we have here, it's a little bit too, let me just log this one in so that we can kind of check it from 2 angles. It's a little bit too yellow, I feel like, because the interior is too yellow, right? So what we want to do is we want to find, first of all, we want to select the post-process volume, and we want to find our temperature, color grading, temperature, white balance, and we just want to decrease the temperature ever so slightly. I think 6000 will do the trick, right? So this is before, this is after, before, after. I'm looking at this color, and I want it to be a little bit closer to white, maybe 5800. Yeah, something like that. Before, after, before, after. Okay, so that is taken care of. Then in terms of global illumination, same thing. We do scene detail up to 2, scene lighting quality up to 2, final gather quality up to 2. Much more importantly, under reflection quality up to 2. Maximum reflection bounces up to like 3 or 4. 4 will do the trick. Do I want to make this darker? I don't really. I think the brightness values are fine, so we don't really need to mess with it too much. There's still a little bit of grain going on there, but that sound. There's a little bit of grain going on there, but besides that, everything is fine, right? It just works. So we're happy with that. All right. What else is there? Vignetting. The post-process volume, in this case, I didn't vignette, vignette, yes, vignette intensity. Just give it a little bit of vignetting, 0.55 maybe. Just darkens the corners a little bit more so that your focus is on the center of the screen. Just a nice effect. Okay, with this, all of our settings are now finished, when we're ready to actually publish our project, you know, to actually export it. Sweet. So, file, save everything, save all, and go to platforms. And now we're publishing just as an Excel file that is going to be used, but that you can send to anyone so that they can open it. This is not going to be the publishing for the internet. That is going to be a little bit different, but as an Excel file, you go to platforms, Windows, either development or shipping, doesn't matter. I'll go for shipping. And then you package the project. It asks you where do you want to save it. I'll save it to desktop. No, I actually let's save it to furniture package, and I'll just call it YouTube. Select. It makes a nice sound and it starts packaging your project. This takes, the first time you package it, it takes a long time, right? So it's going to go through all of the different things that you have in your scene, is going to condense them, see if there are any errors and so on, and eventually it's going to package everything. This might take up to an hour to do. Almost rendering, right? But once it's done, then we will continue the video and I'll explain everything from there on out. We are done. It took us 10 minutes to do, which is considerably faster compared to the previous publish that we've done. And now with our YouTube product.exe ready, let's take another look at it, shall we? Works exactly as expected. I believe. Yes, changing the camera as well as the explode construct does trigger the nice sound now. Changing the styles works. Jumping into the interior scene works. All of the cameras are stable. And now we also, let's change the view to here. We also have the little X button here that we can press to turn off our app. And for all intents and purposes, we are done with the course. I hope you enjoyed it. With that being said, there's also one small addition, the Arcane Mirage service. I'm not sponsored by them. They're not paying me to say this. I just find that service to be quite useful. It's basically where you can upload your files to be shown to the public on the internet. So all of the heavy lifting is done on the server. Of course, you need to pay for it. So you create an account with them, you register, let's see. I suggest that you register for the cheapest plan that they have, which is $25 per month. And for that, you can host up to 3 projects with them. Having 350 tokens per month. Tokens are basically used as minutes at a server, right? So think of it that way. So when a client looks at your project, it's basically 1 token per minute for a weak server, 2 tokens per minute for an average server, 3 tokens for a pretty powerful server, right? Right, on the client side. So you can have, let's say from a powerful server, around 300 minutes of showing time per month per client. If you need more, then you can buy more tokens, but I have a whole video about Arcane Mirage on my channel. I'll leave a link in the video to that video in the video description below if you're interested. But that's basically how it works, right? In terms of project size, up to 8 gigabytes, it's very hard to reach 8 gigabytes with the projects that we do. I think ours right now is around 1 gigabyte. Let's see. 1.4, still pretty small. Currently, Arcane Mirage uses Linux-based platform, meaning that packaging for Linux is tricky. But at the time of publishing this video, they will probably have already moved to onto Windows-based platform, right? Meaning that the file that we have just published right here in the Windows, if you just simply zip it, add to archive, zip up, come on, I can do it. There we go. If you simply create a zip file, you can use that to actually create your project, right? So when you create a new project, you would upload the zip file here. And just to explain further, let me cancel out of that and let me just show you the settings of this bad boy right here. So as you can see, I have this uploaded as a Linux type of a package. It's exactly the same thing as what we've done here. I have changed my setup to use RTX A5000, so a beefier graphics card. I just want it to be as smooth as possible, meaning that every time you click on the link in the video description below and you look at it for a minute, it costs me 3 tokens. Don't look at it too much, please. But you get the idea. So I'm very excited that every single one of you who's been following this course is now going to be able to upload your projects, your Windows packaged projects into Arcane Mirage and share them with the public. There's also, this is an important note, which I find to be quite necessary to state. When you share your project, when you click these 3 dots, you can embed your project, meaning you can get this script or iframe window and you can add it. I believe iframe should work with just a simple href, right? Oh, sorry, HTML, right? Let me just quickly test one thing. HTML and then we need the body, right? Body and then we just add the iframe. Will this work? I think it should. So testing website, all files .html. Save that. Let's see if opening up this one. No, there's probably a little bit more to it than that to make this work. Apologies. But either way, you're able to embed your files right here, right? Through this app onto your own website. I find that to be quite useful as well, and I'll be using it quite a bit. With that being said, let's actually end on the note of us actually looking at it on the server. So with that being said, of course I haven't touched upon too many, like I've skipped over many things, and even with that we're at like 7 hours, which is crazy. But I hope that you've learned a lot of new things and that you will be using this knowledge, there we go, using this knowledge in your own projects, right? Not just kind of repeating the one that we've done together. And if you are going to be using this, please share it in the comments below. I really wanna see it. I wanna see what you come up with, right? So share, show it off. I'll see you in the next one. Later. Oh, leave a like. Bye.